Hello and welcome to Sleepy Science. What if reality is not as solid, direct or complete as your mind makes it feel? What if the world you see is already delayed? Your brain is quietly editing the present. Color is a private simulation inside your skull, and your memories are rebuilt every time you touch them. What if space has no center? Time has no single universal now. Empty space is not truly empty, and the universe you call everything may only be a tiny bubble of something far deeper. In this calm journey, we'll move through perception, consciousness, quantum physics, black holes, cosmic expansion, hidden information, and the strange limits of what can ever be known. These are not fantasy ideas. They are real scientific questions that make ordinary reality feel unstable, mysterious, and much larger than it appears. So before we begin, tell me in the comments, which idea makes reality feel the most unreal to you? Tap like if you enjoy calm science that bends the familiar world. Subscribe for more deep, sleep-friendly journeys. And now, let's step quietly into the hidden layers of reality. The world you see is already gone before you notice it. By the time reality becomes a picture inside your mind, the real moment has already slipped away. You feel as if you are living at the exact edge of now, as if your eyes open and the world instantly appears, fresh, direct, untouched. But the brain does not receive reality like an open window receives sunlight. It receives scattered signals, tiny fragments of information arriving through the eyes, ears, skin, and body, and then it quietly builds them into the scene you believe you are experiencing. The face in front of you, the movement of a hand, the sound of a voice, the shape of a room. None of these enter awareness at the same instant they happen. Light must be detected by cells in your eyes. Nerve signals must travel. Different areas of the brain must identify edges, motion, color, depth, meaning, and emotional importance. Only after this hidden work does the world appear as something simple. A person smiling, a door closing, a bird crossing the sky. The shocking part is not that this takes time. The shocking part is that you never notice the delay. Your brain hides the gap so perfectly that you mistake a processed reconstruction for immediate reality. In a very real sense, consciousness is always arriving slightly late, like a quiet witness stepping into a room after the event has already begun. This is why perception is not just seeing. It is interpretation under pressure. Your brain has to make sense of the world quickly enough for you to survive. So it does not wait for perfect certainty. It predicts. It fills in. It smooths over the missing pieces. When your eyes jump rapidly from one point to another, which they do many times every second, you do not experience the world as a violent blur. Your brain suppresses much of that visual chaos and stitches the moments together, giving you the illusion of a steady scene. When an object moves quickly, your brain often estimates where it is going to be, because reacting only to delayed information would make you too slow. This is one reason athletes can hit a ball moving faster than conscious thought can fully analyze. The body is not simply responding to the present. It is working with a prediction of what the present is about to become. Even ordinary life depends on this hidden forecasting. Crossing a street, catching a falling phone, turning toward your name in a crowded room. All of it relies on a nervous system that is slightly behind reality but constantly guessing forward. And this creates a strange, almost dreamlike truth. The world you experience is not the raw world, but the brain's best usable version of it. It is close enough to guide you, stable enough to trust most of the time, but not identical to what exists outside your skull. Scientists can demonstrate this with illusions, where a flash appears to lag behind a moving object, or where your awareness of a decision seems to come after the brain has already begun preparing an action. These are not just party tricks. They reveal the machinery beneath experience. They show that the present moment is not a pure point in time, but a small edited window, carefully assembled so you can function without feeling the chaos underneath. And when you look beyond the body, the idea becomes even larger. The sun you see in the sky is not the sun as it is this instant, but sunlight that has traveled for several minutes before reaching Earth. The stars at night are even older messages, some arriving after years, centuries, or far longer journeys through space. The universe does not show itself live. It sends evidence, and your mind turns that evidence into presence. But the same thing is happening close to you too, just on a scale too small to feel. The room around you is not entering your awareness directly. It is being delivered, translated, delayed, and assembled. This does not mean reality is fake. It means your access to reality is biological. You are not a ghost floating in direct contact with truth. You are a living body trying to keep up with a moving world. And maybe this should change the way you think about certainty. If even the simple act of seeing depends on delay and reconstruction, then your experience is more fragile, more creative, and more mysterious than it seems. The present you feel so strongly is partly memory, partly prediction, partly sensory evidence, and partly the brain's quiet confidence that it has built something good enough to live inside. So the next time you look at your hands, or watch rain slide down a window, or see someone turn toward you before speaking, let the ordinary become unfamiliar for a moment. What you are seeing is already gone, yet somehow it has become real inside you. Your mind is forever gathering the past and dressing it as now. And maybe that is not a flaw in human consciousness, but one of its most beautiful miracles. You never truly touch the instant itself, and still, from its fading traces, your brain creates a world vivid enough to love, fear, question, and call your life. Your brain may be hallucinating reality in a controlled way. What if the most convincing hallucination you have ever experienced is the ordinary world around you right now, not a wild fantasy, not a break from reality, not something unreal in the simple sense, but a carefully controlled inner construction that your brain keeps correcting with evidence from the senses? This is one of the most fascinating ideas in modern neuroscience. Your brain does not merely wait for the outside world to enter. It actively prepares a version of the world before all the details arrive. It uses memory, expectation, context, and past experience to guess what is most likely happening. Then it compares that guess with signals from your eyes, ears, skin, and body. When the guess fits well, you experience a smooth reality. When it fails, you notice surprise, confusion, or an illusion. That is why you can read a messy word even when some letters are unclear, recognize a friend from a distant outline, or hear a familiar phrase in a noisy room before every sound is perfectly clear. Your brain is not cheating you for no reason. It is helping you move through an overwhelming world without needing to analyze every tiny piece from scratch. If perception were only raw data, life would be too slow, too fragmented, too heavy. So the brain compresses the chaos into meaning. It turns shadows into objects, vibrations into voices, chemical traces into smells, and shifting light into a world that feels solid enough to trust. But this power has a strange side. Because the brain is always guessing, it can also guess wrong. You may hear your phone vibrate when it did not. You may sense someone staring at you in a dark room because your mind is already prepared for danger. You may see a face in the front of a car, in the pattern of a wall, or in the surface of the moon, because the brain is deeply biased toward finding living things, especially faces. This is not stupidity. It is survival logic. A brain that sometimes mistakes a shadow for a threat is safer than a brain that ignores a real threat until it is too late. In this way, reality as you experience it is not a perfect mirror. It is a useful story under constant revision. The world pushes against the story, correcting it, grounding it, forcing it to stay close to what is actually there. But the story is still being written inside you. This is why two people can enter the same place and experience it differently. One person feels peace in silence. Another feels loneliness. One hears confidence in a voice. Another hears arrogance. The same sensory world is filtered through different histories, fears, memories, and expectations. Your brain does not only ask, "What is here?" It also asks, "What does this mean for me?" And that question changes everything. Even pain can be shaped by expectation. The same sensation may feel more intense when you believe it is dangerous. and less intense when you feel safe and understood. This does not mean pain is imaginary. It means experiences built by the body and brain together from both signal and meaning. That is the controlled hallucination. Not a fake world, but a living model. A guided dream with reality holding the reins. And once you understand this, you begin to see your own perception with more humility. Your certainty may feel like truth, but sometimes it is only your brain's strongest prediction. Your fear may feel like evidence, but sometimes it is only a model built from old alarms. Your first impression may feel immediate, but sometimes it is a shortcut wearing the mask of knowledge. The goal is not to distrust everything you see, because your brain is often remarkably accurate. The goal is to remember that seeing is an active process, not a passive one. You are not trapped in a lie. You are living inside an interpretation that can be updated. And perhaps that is quietly hopeful. Because if your brain builds your experience, then awareness gives you a small doorway into the building process. You can pause before believing every fear. You can question the meaning your mind attaches to a look, a silence, a memory, a sound in the dark. You can let reality correct you gently. So as you sit here, listening, breathing, feeling the world around you become familiar again, remember this. Your brain is not showing you reality like a camera. It is singing reality into a form you can survive. And the song is beautiful, useful, imperfect, and unfinished. You could be missing huge parts of reality right now. There is an invisible world pressing against you from every direction, and the only reason it feels empty is that your body was never built to notice most of it. You move through life believing reality is the sum of what you can see, hear, smell, touch, and taste. But your senses are not open gates. They are narrow filters, shaped by survival rather than completeness. Your eyes catch only a thin slice of light, the small band your brain turns into color, while beyond it stretch infrared, ultraviolet, radio waves, X-rays, and other forms of electromagnetic energy that pass through the world without becoming part of your natural vision. A flower that looks plain to you may carry ultraviolet patterns that guide bees like hidden landing lights. A warm animal in darkness may be nearly invisible to your eyes, while some snakes can detect its heat through specialized organs. The air around you may seem silent, yet elephants can communicate with low sounds below your hearing, and bats can navigate with high sounds above it, building a map of the night from echoes you would never know were there. Even the planet itself has signals you cannot feel. Some birds use Earth's magnetic field as part of navigation, while you walk across the same invisible structure with no inner compass strong enough to reveal it. This does not mean humans are broken. It means every creature lives inside its own version of reality, carved from the same universe, but edited by different bodies. A dog does not simply smell more strongly than you. It enters a world where scent carries histories, trails, identities, and emotional traces that are mostly sealed away from human awareness. A shark can detect tiny electrical signals in water. Certain insects can see polarized light patterns in the sky. Microscopes reveal living worlds in a drop of water that your eyes would call clear. Telescopes reveal galaxies in patches of darkness that once looked empty. Instruments do not create these hidden layers. They expose the fact that your natural senses were only ever giving you a local translation. You are not standing before the full universe. You are standing before the human accessible version of it. And this should make the ordinary feel strangely deeper. The space between you and the wall is not truly empty. It carries light you cannot see, heat you barely sense, wireless signals moving through the room, particles passing through your body, air currents carrying chemical traces too faint for you to name. The quiet night outside may be full of animal calls beyond your hearing, magnetic directions beyond your feeling, and light beyond your sight. Reality is not hiding in a mystical way. It is simply larger than the doorway your nervous system can open. And once you understand this, certainty becomes more fragile but also more beautiful. You begin to realize that what you call the world is only the portion of existence your body can afford to process. Your senses give you enough to survive, to love, to build, to avoid danger, to find meaning, but not enough to claim you see everything. So the next time you look at a dark room, a silent forest, a blank sky, or an empty space, remember that emptiness may only be a human word for beyond my range. You may be missing huge parts of reality right now, not because they are distant, but because they are too subtle, too fast, too small, too vast, or too unfamiliar for your senses to translate. And maybe that is the quiet lesson. The world is not small because you cannot perceive it. Your perception is small because the world is immense. The present moment might be a trick your brain invents. The present moment feels like the one thing you can trust, yet it may be one of the brain's most elegant inventions. You feel yourself sitting inside a sharp, living now, a single bright point between what has already happened and what has not happened yet. But when scientists look closely at human experience, the present does not behave like a perfect instant. It behaves more like a small mental window, wide enough for the brain to gather separate events and make them feel like one continuous moment. A melody is a simple example. You never hear a song as isolated notes floating alone. Your mind holds the note that just passed, combines it with the note arriving now, and leans toward the note it expects next. Without that short bridge across time, music would collapse into disconnected sounds. Speech works the same way. You understand a sentence because your brain keeps the beginning alive while the ending arrives. Even movement depends on this quiet blending. A bird crossing the sky does not appear to you as thousands of frozen positions. It appears as motion because the brain weaves change into continuity. This means the present you experience is not a knife edge. It has thickness. It contains a little memory, a little sensation, and a little expectation, all pressed together so tightly that you call it this moment. And the trick becomes even stranger because your sense of now can stretch or shrink depending on your state. During fear, time may seem to slow, not necessarily because the outside world changes, but because attention becomes intense and the brain records more detail than usual. During boredom, time can feel heavy and long while it is happening, yet strangely empty when you look back. During flow, when you are deeply absorbed in a task, hours can vanish with almost no resistance. So which one is the real present? The slow one, the fast one, the empty one, the vivid one? The answer is uncomfortable. Your experience of time is partly constructed by attention, emotion, memory, and bodily arousal. The clock may keep counting evenly, but the mind does not live inside clock time. It lives inside experience time, and experience time is flexible. This is why childhood summers can feel enormous in memory, while adult years may seem to pass faster. New experiences leave more markers for memory to hold on to. Repeated routines compress into a blur. A life with fewer new impressions may not literally move faster, but when you look back, it can feel thinner, as if whole months were folded into a single pale page. The brain is not only measuring time, it is giving time texture. It decides what becomes dense, what becomes light, what becomes important enough to feel long. And this should make you wonder about the now you are inside at this exact second. Is it a place you occupy, or a story your brain is updating? Is the present a real boundary in the universe, or simply the format consciousness uses so you can act, choose, speak, listen, and survive without drowning in separate fragments? Physics does not give us one universal present shared by everything, and neuroscience does not show us a tiny glowing point where now is stored. What we find instead is coordination, systems timing perception, memory, movement, and attention well enough to create the feeling of presence. The present may be less like a location and more like a flame, constantly renewed, never made of the same material twice, yet stable enough to guide you through the dark. This does not make life less real. It makes it more delicate. Every moment you think you possess is already being shaped, stretched, colored, and held together by a mind trying to turn change into meaning. So when you breathe quietly and feel yourself here, do not think of the present as a hard line you can grab. Think of it as a small clearing made by the brain, a temporary shelter between memory and possibility. You are not standing on a fixed point in time. You are being carried by a living illusion of continuity, gentle, useful, fragile. And from that illusion, your entire life unfolds. Reality might be less like a world and more like an interface. Reality may not be a landscape your mind enters, but a simplified control panel your brain uses to keep you alive. You feel as if you are surrounded by the world itself. Tables, walls, faces, trees, roads, clouds, all existing exactly in the form you experience them. But there is a quieter possibility hiding beneath ordinary perception. Maybe what you experience is less like the deep structure of reality and more like an interface, a usable display, built not to show you everything, but to help you act. Think about a phone screen. When you tap an icon, you do not see the millions of electrical events, code instructions, memory changes, and hardware operations happening underneath. You see a simple symbol because that symbol is useful. It hides complexity so you can do something. In a similar way, the world you experience may be full of icons, color as a signal, shape as a handle, distance as a guide for movement, faces as social meaning, danger as tension in the body. This does not mean the world is fake. A file icon is not fake just because it is not literally the file. It represents something real in a form you can use. Your perception may work the same way. A ripe fruit is not merely red in some ultimate sense. Redness, brightness, smell, and texture become a practical message. This might be food. A cliff edge is not given to you as a physics equation. It appears as danger, depth, and hesitation in your muscles. A stranger's expression is not delivered as raw biological data. It arrives as friendliness, anger, uncertainty, or threat. Your mind turns the overwhelming richness of existence into a world of meanings and possibilities for action. Some scientists and philosophers have argued that perception evolved less for perfect truth and more for useful survival. A creature that sees only what helps it eat, escape, mate, cooperate, and avoid harm may survive better than a creature overwhelmed by deeper accuracy. In that sense, your everyday world might be a brilliant compression system. It hides what is too small, too fast, too complex, or too irrelevant for ordinary life, and presents what matters at the human scale. You do not experience atoms when you touch a table. You experience firmness. You do not experience chemical structures when you smell smoke. You experience warning. You do not experience the full machinery of another brain when someone looks at you. You experience a person. The interface is not meaningless. It is intimate, functional, and deeply powerful. But it is not the whole. This is why reality can feel so solid while still being only a surface layer of something deeper. The interface gives you confidence because confidence is useful. It gives you objects because objects are easier to navigate than endless processes. It gives you a self in a world because that is the format your nervous system can manage. But beneath the familiar display, the universe may be less like a room filled with separate things and more like an ongoing web of relations, fields, forces, information, and change. Your brain does not show you all of that. It gives you the desktop version, clean enough to use, stable enough to trust, limited enough to survive. And maybe this should not make you despair. Maybe it should make the ordinary more mysterious. Every cup, every shadow, every face, every streetlight may be both real and symbolic, a surface your mind can understand, covering depths it was never built to fully reveal. So when you look around and feel that the world is obvious, pause gently. Obviousness may be the interface doing its job. The deeper truth may not be that reality is missing, but that reality is too vast to appear directly. And you, moving through this luminous display, are not seeing the final nature of things. You are seeing the version of the universe that a human life can hold. You may never know if anyone else is truly conscious. The strangest prison in the universe may be the one you never notice, because it has the exact shape of your own mind. You can sit across from another person, watch their eyes move, hear their voice soften, see their hands tremble, and still never enter the private room where their experience is happening. You can know their name, their history, their habits, their favorite songs, even the tiny changes in their face when they are trying not to cry, but you cannot directly feel what it is like to be them. This is the old problem of other minds, and it is not just a philosopher's puzzle hiding in dusty books. It is a quiet fact built into every conversation you have ever had. Consciousness is private from the inside. You know your own awareness not because you measured it from outside, but because you are living it. You do not infer your pain in the same way you infer another person's pain. When you are hurt, the experience is immediate. When someone else is hurt, you read signs. A tightened jaw, a sharp breath, a word, a tear, a change in posture. Those signs may be honest, and most of the time they are enough for human life. But they are still signs. Brain scans can show activity linked with emotion, perception, attention, or pain, but they do not open a window into the felt texture of another person's inner world. A machine can record patterns, but it cannot hand you the actual redness they see, the exact grief they carry, or the secret weight of a memory as it feels from within. This is why even deep empathy has a boundary. When you comfort someone, your brain may mirror aspects of their emotion, and your imagination may build a careful model of their suffering, but you are still meeting them through your own nervous system. You are translating them into you. That does not make compassion fake. It makes it even more remarkable. Human connection exists across an unbridgeable gap, and still we reach. We listen, we trust, we build love from clues, and this uncertainty becomes sharper in the age of artificial intelligence, because behavior alone is becoming harder to interpret. If something speaks fluently, responds emotionally, and appears to understand, does that mean there is experience inside it, or only convincing performance? The uncomfortable truth is that we do not yet have a simple test that proves consciousness from the outside. We can test memory, intelligence, language, reaction, and self-report, but the inner light itself remains hidden. And the same mystery, in a softer form, has always existed between human beings. You assume others are conscious because they are built like you, behave like you, suffer like you, and because society would collapse if we treated every mind as doubtful until proven real. In daily life, that assumption is not weakness. It is moral wisdom. Since you cannot access another person's inner world directly, the safest and most humane choice is to act as if that world is real, deep, and vulnerable. This is where the question stops being cold and becomes tender. You may never know with perfect certainty that anyone else is truly conscious, but every act of kindness is a wager that they are. Every apology, every gentle word, every moment of patience says, I cannot enter your experience, but I will honor it anyway. And maybe that is what makes consciousness so haunting. It is the most intimate thing in existence, yet it can never be fully shared. Each person is a lit house seen from the street at night. You can see movement behind the curtains. You can see warmth in the windows. You can knock, speak, wait, and be answered. But you can never fully step inside. So you live by trust. And perhaps trust is not a weakness in our knowledge, but the bridge that lets separate islands of awareness become a world. The self you call you might be a temporary brain story. Somewhere inside your skull, a storyteller is working so smoothly that you mistake its voice for yourself. You wake up each day with the feeling that there is one continuous you behind your eyes. The same person who went to sleep last night, the same person who remembers childhood scenes, makes choices, carries preferences, fears embarrassment, protects dignity, and says, almost without thinking, this is who I am. But neuroscience suggests that the self is not a single object hidden in the brain, like a pearl inside a shell. It is more like a story being constantly updated by many systems working together. Memory, emotion, body sensation, attention, language, social feedback, and the brain's need to explain its own behavior. You do not experience all these systems separately. You experience their combined result as identity. That is why the self feels solid, even though it is built moment by moment. Your brain gathers signals from your body, hunger, heartbeat, tension, fatigue, warmth, pain, and combines them with memories, goals, habits, and the situation around you. From this mixture, it creates a feeling of being someone located here, moving through a life that belongs to you. But this someone can change more easily than it seems. A person with certain brain injuries may become more impulsive, less emotionally controlled, or strangely different in personality, not because their soul has vanished, but because the systems supporting their usual self have been altered. In split brain studies, where communication between the brain's hemispheres is surgically reduced to treat severe epilepsy, researchers found something deeply unsettling. One part of the brain could initiate an action, while the speaking part invented a reasonable explanation afterward. The person was not deliberately lying. The brain was doing what it often does, creating a coherent story from incomplete information. This is called confabulation, and milder forms of it appear in ordinary life more often than we like to admit. You may think you know exactly why you chose something, why you dislike someone, why you suddenly felt sad, why a certain memory matters. But sometimes the explanation comes after the feeling, after the reaction, after the behavior. The narrator arrives late and speaks with confidence. This does not make you fake. It means the self is partly an interpreter, not just a commander. It watches the body act, listens to emotion rise, observes habits unfold, then says, "I meant to do that," or "This is what I wanted," or "This is who I am." And the story becomes even more fragile when you look at memory. You do not carry a perfect archive of your past. You carry fragments that help maintain continuity. Your brain selects certain moments, gives them meaning, connects them into a life story, and leaves out countless others. You say, "I have always been this way," but often that is a narrative shortcut. The child you were, the teenager you were, the person you were 5 years ago may have wanted different things, feared different judgments, believed different truths. Yet the mind stitches these versions together and gives them one name. That name feels stable because the story needs stability. Without it, life would become psychologically unbearable. You need a self to make promises, learn from mistakes, build relationships, plan tomorrow, and feel responsible for yesterday. The self may be constructed, but it is not useless. A bridge is constructed too, and you can still cross it. The danger is not that the self is a story. The danger is forgetting that it is a story and becoming trapped inside one version of it. People say, "I'm just an anxious person. I'm not creative. I always fail. I can never change," as if identity were a prison sentence written into the bones. But the brain is plastic. It changes with repetition, environment, practice, relationships, trauma, healing, sleep, stress, and attention. The story of you can harden, but it can also soften. It can be revised, not by pretending the past did not happen, but by understanding that the past is not the only author. This is where the idea becomes quietly powerful. If the self is a temporary brain story, then you are not less real. You are less fixed. You are not a statue. You are a pattern. You are a process that remembers itself, protects itself, explains itself, and sometimes mistakes its explanations for truth. The you listening right now is not exactly the same as the you who began this sentence. Tiny shifts have already happened. New thoughts, new associations, new traces in the nervous system. Most are too small to notice, but life is built from these small revisions. So perhaps the question is not who am I really, as if there is one final answer buried somewhere deep inside. Perhaps the better question is, what story is my brain telling about me? And does that story still help me live? Because if your identity is partly a living narrative, then awareness becomes a kind of authorship. You can listen to the narrator without obeying every line. You can question old labels. You can let the self become less like a cage and more like a river, continuous enough to recognize, changing enough to remain alive. And maybe that is the soft truth beneath the fear. The self you call you may be temporary, but its temporary nature is also what makes growth possible. Your memories are not stored. They are rebuilt every time. A memory can feel like a sealed recording from your past, but every time you open it, your brain may be quietly rewriting the tape. You probably imagine memory as a kind of inner library, with moments stored on shelves, waiting to be taken down exactly as they were. Your first school day, an old argument, the smell of a childhood room, the face of someone you miss. All of it feels as if it has been preserved somewhere inside you, untouched, until you return. But the brain does not store most memories like finished videos. It stores patterns, fragments, associations, emotional tones, body states, places, names, and meanings, then rebuilds an experience when you remember it. The act of remembering is not simple retrieval. It is reconstruction. When you recall an event, the brain gathers pieces from different systems and assembles them into something that feels whole. The hippocampus helps link parts of an experience together, while other regions support emotion, sensory detail, language, and personal meaning. This is why a memory can feel vivid and still be inaccurate. Vividness is not proof. Confidence is not proof. A person can remember the color of a room, the exact words someone said, or the order of events with complete emotional certainty, and still be wrong. This is not because the person is dishonest. It is because memory is alive. Each time a memory is reactivated, it can become flexible for a while before being stored again, a process scientists often describe as reconsolidation. During that vulnerable window, new information, current emotion, suggestion, or later knowledge can blend into the old memory. That is why family stories can change what you think you remember. A photograph can strengthen a scene but also distort it. A question like, "How fast was the car going when it smashed into the other car?" can influence how people later remember an accident compared with a softer word like hit. Eyewitness memory, once treated as powerful evidence, has been shown again and again to be fragile, especially under stress, fear, poor lighting, or pressure from authority. Your brain is not built to preserve every detail. It is built to preserve meaning, danger, identity, and lessons for the future. It keeps what seems useful and lets the rest fade. But when gaps remain, the mind may fill them so smoothly that the filling feels original. This is why two people can share the same day and carry different versions of it for years. One remembers the insult, another remembers the silence, one remembers the weather, another remembers only the feeling of being left out. Memory is not a courtroom transcript. It is a living map drawn by a nervous system trying to understand where it has been and where it must not go again. And emotion is the ink that makes some lines darker. Fear can make a memory feel burned into you, but even traumatic memories are not perfect recordings. They can be intense, fragmented, sensory, and difficult to place in time. Joy can glow brighter than the details that actually produced it. Nostalgia can soften the past, sanding down boredom and pain until an ordinary year becomes golden in hindsight. Even your sense of who you are depends on this fragile rebuilding. You do not carry your life as a complete archive. You carry selected scenes, repeated stories, wounds that became warnings, victories that became proof, embarrassments that became rules, and moments of love that became shelter. Then your mind connects them and says, "This is my past." But perhaps your past is less like a stone wall and more like a garden path that changes slightly each time you walk it. The footprints remain, but the soil shifts. The light changes. New growth covers old edges. This does not mean your memories are meaningless. It means they are human. They are attempts to preserve experience in a brain that must keep changing to stay alive. So, when a memory rises tonight, a voice, a room, a mistake, a person you used to be, hold it gently. It may contain truth, but not the whole truth. It may be teaching you something, but it may also be carrying edits you never noticed. And maybe the deepest lesson is this: you are not only shaped by what happened to you, but by how your brain keeps rebuilding what happened. The past is gone, yet it still changes inside you, quietly, patiently, every time you remember. Your brain can make decisions before you feel like you chose. Before you say, "I decided," your brain may have already begun moving toward the choice in silence. This is not the same as saying you are a puppet, or that free will is completely false, but it does disturb the simple story most of us carry, that a conscious you sits in command, examines the options, gives an order, and then the body obeys. In real life, the brain is often preparing actions before awareness catches up. In famous experiments by Benjamin Libet and later researchers, people were asked to make simple movements, like flexing a wrist or pressing a button whenever they felt like it. Scientists found that measurable brain activity linked to preparation could appear before the person reported the conscious feeling of deciding. The choice felt immediate from the inside, but the nervous system had already started leaning toward action. That does not mean the experiment proves all human choices are secretly made without you. Choosing a career, forgiving someone, resisting temptation, or changing your life is far more complex than pressing a button in a lab. But it does reveal something important. The feeling of conscious choice may not always be the beginning of a decision. Sometimes it may be the moment a deeper process becomes visible to itself. Your brain is constantly evaluating before you speak, weighing habits, emotions, memories, body signals, risks, rewards, social pressure, and past experience. Much of that work happens below awareness because if you had to consciously inspect every reason behind every tiny action, life would become impossibly slow. You reach for a glass, turn away from a strange noise, choose a seat, answer a familiar question, or pause before sending a message. And only afterward does the conscious mind often provide a clean explanation. I wanted that. I thought it was safer. I just felt like it. The explanation may be partly true, but it may also be a story placed on top of many hidden influences. This is why advertising works, why habits can feel automatic, why mood can shift your choices without announcing itself, and why hunger, sleep loss, stress, or fear can make you decide differently while still feeling like the same rational person. The mind does not always reveal its machinery. It gives you the final scene, not every rehearsal. And yet there is a hopeful side to this. If many choices begin before conscious awareness, then freedom may not be a single magical spark at the last second. It may be something slower and deeper, the ability to train the conditions from which your choices arise. You may not control every impulse the instant it appears, but you can shape your habits, your environment, your attention, your values, the people around you, the stories you repeat, and the pauses you create before action. A person trying to change is not trying to overpower the brain from outside. They are teaching the brain what kind of future to prepare for. This is why practice matters. This is why reflection matters. This is why sleep, stress, and emotional patterns matter. The unconscious is not your enemy. It is the hidden workshop where much of your life is assembled before you see the finished object. So when you notice yourself saying, "I don't know why I did that," do not treat it only as failure. Treat it as a clue. Something beneath awareness moved first. Something in you learned a pattern and followed it. The question is not whether you are perfectly free in every instant, because you are not. The question is whether you can become aware enough to influence the deeper systems that choose with you. Maybe the self is not a king giving commands from a throne, but a quiet gardener tending the soil from which actions grow. And if that is true, then responsibility becomes less about controlling every thought and more about patiently shaping the mind that will think tomorrow. You don't see with your eyes. You see with a prediction machine. Your eyes do not show you the world. They send your brain clues, and your brain builds the scene before you realize there was a mystery to solve. This is why vision feels so effortless, even though it is one of the most complex things your nervous system does. You open your eyes and believe the room simply appears, but the eyes are not tiny cameras streaming a perfect movie into consciousness. They are biological sensors, limited, selective, and incomplete. The retina at the back of each eye does not just passively collect light. It begins processing contrast, edges, movement, and changes before the information even reaches the brain. Then the brain takes those signals and compares them with what it already expects from past experience. It asks, silently and constantly, what is most likely here? What shape would make sense? What object is this probably part of? Where should this movement continue? You do not notice this questioning because the answer arrives as sight. But sight is not raw light. Sight is the brain's best prediction, corrected by incoming evidence. One of the clearest clues is how little detail you actually see at once. Only a small central area of your vision is sharp enough for fine detail, the area you use to read these words or study a face. The rest of your visual field feels rich, but much of that richness is partly assumed. Your eyes jump around several times every second, sampling pieces of the world, while the brain creates the impression of a wide, stable, detailed scene. It is as if your mind is painting a mural from quick glances and then hiding the brushstrokes. This predictive system is why you can recognize a chair from only its outline, understand a half-hidden object behind a curtain, or know that a moving car has not vanished just because a tree briefly blocks it. The brain does not wait for full information. It uses what it knows about objects, depth, light, and movement to keep the world coherent. Most of the time, this is incredibly useful. Without prediction, every shadow would be confusing. Every partially covered object would become a new puzzle, and every movement would arrive too late to respond to smoothly. But the same system can mislead you. In certain visual illusions, your brain sees depth where there is only a flat image, motion where the picture is still, or a shape that is not actually drawn because surrounding lines strongly suggest it. This happens because perception is not only about what enters the eye, it is about what the brain believes the evidence means. Your brain is not trying to deceive you. It is trying to be fast, useful, and stable in a world that changes too quickly for perfect analysis. This is also why context can change what you see. A mark on a page may look like one letter inside one word and a different letter inside another. A grey square may appear lighter or darker depending on the shadows around it. A face can look angry or tired depending on what you already expect from the situation. The signal may be similar, but the prediction changes the experience. This should make you pause because it means seeing is not a simple act of receiving reality. It is a collaboration between the outside world and the brain's internal model. The world provides resistance. It corrects the model when the prediction fails. But the model is always there, shaping the first version of what you believe you see. And perhaps this is why human vision feels so natural. The brain is not showing you every photon, every surface, every uncertainty. It is giving you a practical world of objects, paths, faces, threats, tools, and meanings. It turns light into a place you can live. So the next time you look at a familiar room, do not imagine your eyes as windows and your mind as someone standing behind them. Imagine your brain as a quiet architect, using the eyes as messengers, building reality from hints, memories, expectations, and corrections. The world you see is not invented from nothing, but it is not delivered whole either. It is predicted into shape, tested against evidence, and refreshed faster than thought. And somewhere inside that invisible process, light becomes home, shadows become depth, movement becomes intention, and you begin to believe you are simply seeing. The night sky is a graveyard of ancient light. The night sky is not a ceiling of lights above you. It is a graveyard of ancient messages, still arriving long after the moments that created them have vanished. When you look upward, it feels as if the stars are simply there, shining together in one quiet present. But that calm image is one of the most beautiful illusions nature gives you. Every point of light in the sky is a traveler. It left its source and crossed space before it ever touched your eye, which means the night sky is not a live scene, but a layered history. Some stars you see are only a few years away in light travel time, while others are hundreds or thousands of years away. When their light began moving toward Earth, human civilizations may have looked different, languages may have changed, cities may not yet have existed, and the people who first lived under that same sky may have been gone for generations before the light finally reached you. This is what makes stargazing quietly unsettling. You are not only looking across distance, you are looking across time. The sky becomes a museum without walls, where every star is displayed not as it is now, but as it was when its light began the journey. Even constellations, those familiar shapes people have named for thousands of years, are not real groups in the way they appear to us. The stars in a constellation may sit at wildly different distances from Earth, unrelated except by the accident of our viewpoint. From another part of the galaxy, Orion, the Big Dipper, or any familiar pattern might dissolve completely, because those shapes are not carved into space. They are human drawings placed over scattered depths. And behind the stars you can see with your eyes there are older and fainter histories. The pale band of the Milky Way is the combined glow of countless distant stars, dust and structure inside our own galaxy, a vast stellar city seen from within. Some of that light has traveled so long that by the time it reaches you, the star system that sent it may have changed, aged, or moved. Telescopes deepen this feeling even more. When astronomers study distant galaxies, they are not seeing them as they are today. They are seeing them as they were millions or billions of years ago, because their light has spent that long crossing the expanding darkness. A telescope is therefore not only a tool for seeing far away, it is a time machine made of glass, mirrors, patience, and physics. It does not send you into the past. It lets the past arrive. And perhaps the strangest part is that light carries information with astonishing honesty. By spreading starlight into its colors, scientists can learn what a star is made of, how hot it is, how fast it is moving, and whether it is approaching or receding. A tiny stream of ancient light can reveal hydrogen, helium, metals, motion, temperature, and history. The star does not speak, yet its light arrives like a letter written in physics. This means the darkness above you is not empty silence. It is a library of delayed evidence. Every starbeam is a fossil, not made of bone or stone, but of radiation that survived the journey through space. And this changes the emotional weight of looking upward. The night sky is beautiful, yes, but it is also full of endings, distances, and unreachable pasts. You are seeing fires that may have changed beyond recognition, worlds that may have formed or died around them, galaxies whose light began traveling before Earth had anything like human eyes to receive it. Still, when that light finally reaches you, it becomes part of your nervous system for a brief instant. Something ancient crosses the universe and ends as a spark of awareness inside a living mind. So the next time you stand beneath the stars, do not think of the sky as decoration. Think of it as time made visible. Think of it as the universe showing you its old wounds and old fires, not all at once, but one photon at a time. Above you is not just space. It is memory on a cosmic scale, still falling gently into your eyes. Some stars you see may no longer exist. A star can keep shining in your sky after the star itself has changed, collapsed, or disappeared from the form your eyes believe they are seeing. This sounds like a ghost story written by astronomy, but it is simply what happens when distance and time are woven together. A star is not a lamp hanging above the earth in the same immediate moment as you. It is a violent living furnace, held together by gravity and fed by nuclear fusion, sending light outward into space long before that light becomes part of your night. And because light needs time to travel, the star you see is always an earlier version of that star. For most stars visible to the naked eye, this does not mean they are probably gone. Many are relatively nearby in cosmic terms, and stars often live for millions, billions, or even trillions of years, depending on their mass. The small, cool stars can burn so slowly that their lives stretch far beyond the current age of the universe. But the bright, massive stars are different. They spend their fuel with terrifying speed, blazing intensely and dying young, compared with stars like the Sun. A massive blue-white star may live only a few million years before swelling, destabilizing, and ending in a supernova or collapsing into a neutron star or black hole. So when you look at certain brilliant stars, especially very massive ones far away, there is always a quiet possibility. The light reaching you belongs to a version of the star that no longer exists in that form. It may have already exploded somewhere in the galaxy, and the news of its death may still be traveling toward us. The sky would not update instantly. There is no cosmic notification, no sudden correction across space. The old light keeps arriving until the final message catches up. This is what makes the idea so haunting. The universe can preserve appearances after the object has moved into another chapter of existence. A star can die, and yet for Earth, it can continue to shine until the last light from its living surface has crossed the distance. In deeper telescopic views, this becomes even more dramatic. Some galaxies are so far away that we see them as they were millions or billions of years ago. Many of the individual massive stars inside those ancient images are certainly gone now. Their lives completed long before humans ever built instruments to catch their glow. What appears as a distant sparkle may be the surviving trace of something that burned, aged, transformed, and vanished before our species even existed. But this is not just a story about death. Stars do not simply disappear into meaninglessness. When massive stars end, they create and scatter heavy elements into space: carbon, oxygen, iron, and many of the materials that later become planets, oceans, rocks, blood, and bone. A dying star can be a catastrophe and a beginning at once. Its explosion can seed future worlds. Its collapse can leave behind objects so dense and strange that ordinary imagination struggles to follow. This means the possible dead star in your sky is not only a lost fire, it may also be an ancestor of future matter, a cosmic ruin that helped make later forms of complexity possible. And perhaps that is why this truth feels so deep. The universe allows you to see not only what exists, but what once existed strongly enough to leave evidence behind. You are surrounded by delayed brightness, by old signals still faithful to the moment that released them. So the next time you notice a star and feel it is simply there, remember that you may be looking at a memory with a heartbeat of light. It may still be burning. It may have changed beyond recognition. It may have already given its body back to space. You cannot know just by looking. And yet its light still reaches you, quiet and precise, touching your eye as if the past were not finished speaking. There is no single now shared by the universe. Somewhere far beyond Earth, two events can happen in an order that depends on who is moving when they look. That sounds impossible, because your mind is trained to believe the universe shares one giant clock, one cosmic now, stretching everywhere at once, as if every star, planet, galaxy, and drifting particle could be frozen on the same universal frame and labeled. This is the present. But modern physics quietly took that comfort away. According to Einstein's relativity, there is no single master moment that all observers must agree on across the universe. Time is not a universal stage lighting up everywhere equally. It is woven together with motion, distance, and the speed at which information can travel. The key is this: nothing can tell you instantly what is happening far away, because information itself has a speed limit. Light, gravity changes, radio signals, every possible message from a distant event needs time to cross space. So when you say something is happening right now on a planet orbiting another star, you are not pointing to a simple fact the universe has stamped into reality. You are choosing a way of slicing space-time based on your own state of motion. Another observer, moving differently, may slice it another way and disagree about which distant events are simultaneous with your present, and both can be correct within their own frame. This is called the relativity of simultaneity, and it is one of the strangest ideas hiding beneath ordinary time. It does not usually disturb daily life because human speeds are tiny compared with light, and the distances around us are small enough that everyone's clocks and nows seem to match. In a room, in a city, even across the earth, the differences are usually too small for your senses to notice. But across cosmic distances, and at very high speeds, the idea of one shared now begins to dissolve. Imagine two lightning strikes happening far apart along a railway track. A person standing halfway between them may see the flashes arrive together and conclude the strikes happened at the same time. But someone racing past in a very fast train may move toward one flash and away from the other, receiving the light differently, and after carefully accounting for motion, may judge the order of those events differently. The point is not that one person is confused or that light tricked them in a childish way. The deeper point is that time and space do not separate as cleanly as intuition wants. What counts as at the same time depends on the observer's motion. The universe does not hand everyone the same cosmic timestamp for distant events. This means the present is not a single sheet spread across all existence. It is more like a local experience, a personal horizon of coordination around you, reliable nearby but not absolute everywhere. And this changes the emotional meaning of time. Somewhere a star may be collapsing. Somewhere else a planet may be forming. A civilization, if one exists far beyond us, may be waking, building, failing, or looking at its own sky. But asking what they are doing right now is not as simple as it feels, because right now is not a universal bridge connecting you to them. It is a human phrase that works beautifully in kitchens, streets, and conversations, then becomes unstable when stretched across the cosmos. Physics does not say distant things are unreal, or that time is imaginary. It says reality is structured in a way that refuses one privileged clock for everyone. Each observer carries their own measure of time through the universe, and the laws of physics remain consistent even when their views of simultaneity differ. That is the quiet miracle. The universe is not chaotic because there is no single now. It is orderly in a deeper way, one where relationships matter more than absolute positions in time. What you call the present is the time that belongs to your path through space-time, your local thread in a vast fabric where other threads cross, tilt, and stretch differently. And perhaps this should make your life feel smaller and larger at once. Smaller, because your now is not the command center of existence. Larger, because every moment you live is part of a structure far more subtle than the ticking clock on a wall. You are not standing inside the universe's only present. You are moving along your own line through time, carrying a private lantern of now with you, while distant realities occupy their own timing beyond your immediate reach. So when you look up and feel that everything out there must be sharing this exact instant with you, pause gently. The cosmos may not have one heartbeat. It may have countless rhythms, each honest, each relative, each woven into the same immense reality. And in that soft unraveling of a single universal now, time becomes less like a ruler and more like music. Not one note struck everywhere at once, but many lines unfolding together, separated by distance, joined by law, and never fully heard from only one place. Time does not flow the same for everyone. Time is not a river that carries everyone at the same speed. It is more like a personal pulse, changing quietly with motion, gravity, and where you are in the universe. This sounds impossible because everyday life trains you to trust clocks as if they reveal one fixed reality. A second feels like a second, whether you are sitting in a chair, walking down a street, or looking up at the sky. But physics shows that time is not absolute. It can stretch, it can slow, it can pass at different rates for different observers, not because their watches are broken, but because time itself behaves differently depending on speed and gravity. If you travel extremely fast, close to the speed of light, time for you would pass more slowly compared with someone who stayed behind. You would not feel your own heartbeat slowing. Your thoughts would not seem delayed. Inside your own experience, everything would feel normal. But when you returned, less time may have passed for you than for the person who waited. This is the heart of the famous twin idea. One twin travels through space at enormous speed, returns, and is younger than the twin who remained on Earth. It is not magic. It is not a fantasy of science fiction. It follows from the way space and time are connected. Motion changes the path you take through space-time, and different paths can contain different amounts of lived time. Gravity does something equally strange. The stronger the gravity around you, the slower time passes compared with a place where gravity is weaker. A clock near sea level ticks ever so slightly slower than a clock on a mountain, because the clock lower down sits deeper in Earth's gravitational field. The difference is tiny, far too small for your body to feel, but atomic clocks can measure it. These are not philosophical guesses. They are practical realities. GPS satellites have to account for time differences caused by both their speed and their position high above Earth. Without correcting for relativity, their timing would drift, and navigation would become inaccurate. So every time a phone map guides someone through a city, it is quietly relying on the fact that time does not flow the same everywhere. That is what makes this truth so unsettling. Relativity is not locked away in distant galaxies or advanced equations. It is already hidden inside ordinary technology, silently adjusted so daily life can appear simple. And if gravity affects time, then the universe is full of clocks that do not agree. Time near a black hole can slow dramatically compared with time far away. Around dense stars, time bends with gravity. Even across Earth, the difference between high altitude and low altitude is real, though extremely small. Your head, being slightly farther from Earth's center than your feet, experiences time at a minutely different rate, too small to matter in life, but real in principle. This means your body is not moving through a perfectly uniform time field. It is living inside a universe where time has texture, smooth here, stretched there, slowed by mass, altered by motion. The familiar ticking of a clock is only the local version of a much deeper story. And this changes how you think about aging, distance, and presence. Aging is not just something that happens because time passes. It is the amount of time your body actually experiences along its own path. Two people can meet, separate, move differently through the universe, and return with different amounts of time written into them. They may have shared a beginning, but not the same duration. The mind wants one master clock because it feels emotionally safer. It wants the universe to be fair, synchronized, evenly paced. But the cosmos is subtler than that. It does not give every traveler the same measure. It gives each path its own time, and maybe this should make every quiet second feel stranger. The moment passing through you right now is not a universal drop of time falling everywhere equally. It is your local rhythm, your small private measure of existence, shaped by where you are, how you move, and the gravity holding you here. You may never feel the difference in your ordinary life, yet the difference is real enough to guide satellites, age particles, and bend the fate of stars. So when you hear a clock ticking, do not imagine it as the voice of the whole universe. Imagine it as one instrument in a cosmic orchestra, keeping time from one place, one motion, one path. Somewhere else, another clock is ticking differently, just as honestly. And between them lies a truth both precise and poetic. Time does not simply flow around you. It belongs to the journey you take. The future and past may be more equal than your mind allows. The future feels unwritten and the past feels sealed. But physics does not always draw that emotional line as sharply as the human mind does. To you, time feels like a one-way road. Yesterday is fixed behind you, tomorrow is open ahead of you, and the present is the thin place where possibility turns into history. That feeling is so deep that it seems obvious. You can remember the past but not the future. You can regret what happened, but you cannot regret what has not happened yet. You can find photographs, scars, fossils, and old messages, but you cannot find a memory from next year waiting in a drawer. So the mind naturally treats past and future as completely different kinds of reality. But when physicists study the deep laws of nature, something strange appears. Many fundamental processes do not clearly prefer one direction of time. In the equations that describe motion, particles, and fields, a process can often make sense forward or backward, at least at the microscopic level. A planet orbiting a star, a molecule moving through space, a particle interaction. Many of these can be described without a built-in label saying, this direction is the real flow. The great difference between past and future seems to emerge not because every tiny law demands it, but because the universe as a whole has a direction of increasing disorder what scientists call entropy. That is why a glass can fall and shatter, but shattered pieces do not normally leap back into a perfect glass. It is not forbidden by imagination. It is overwhelmingly unlikely in practice. The arrow of time you live inside is tied to the way order spreads, heat disperses, memories form, bodies age, and causes leave traces. The past feels fixed partly because it has records. It has evidence. It has shaped the present. The future feels open because it has not yet left records for creatures like us to read. But relativity adds another unsettling layer. If different observers can disagree about which distant events count as simultaneous, then the idea of one universal present becomes fragile. Some physicists and philosophers take this seriously and describe space-time as something more like a whole structure than a moving spotlight. In this view, often called the block universe, past, present, and future may all belong to the complete fabric of reality, while your experience of moving through time is tied to your path inside that fabric. This does not prove that your future is already written in a simple fatalistic way, and it does not mean your choices are meaningless. It means the universe may not divide existence into real past and unreal future as neatly as your mind does. Your mind is built for survival, not for seeing time from the outside. It must treat the future as open, because planning, caution, hope, and effort depend on that feeling. It must treat the past as closed because memory, learning, and identity depend on stability. If your brain experienced all of time as equally present, ordinary life would become impossible. You need the illusion of moving forward in order to act. You need yesterday to feel settled and tomorrow to feel reachable. But at a deeper level, the difference may be less absolute and more relational. The past is the region of time that has left marks on you. The future is the region your actions can still help shape from your perspective. One is known through records, the other is approached through expectation, and between them stands consciousness, converting physical structure into lived drama. This is why the thought feels both cold and strangely peaceful. If the past and future are more equal than your mind allows, then your life is not a tiny spark being erased instant by instant. It may be more like a complete line drawn through space-time, with every moment holding its place in the larger pattern. The child you were is not nowhere. That moment existed as truly as this one. The future person you may become is not yet accessible to memory, but may still belong to the shape your life is making. You cannot step outside time and look at the whole design, but you can feel its edge whenever memory and hope meet. So, perhaps the question is not whether the future is already there in a way that removes freedom. Perhaps the better question is why the universe gives rise to beings who experience time as a story. Maybe the arrow of time is not just a physical fact, but the condition that allows meaning to exist at all. A song only becomes music because one note follows another. A life only becomes a life because you do not receive it all at once. You are protected from the whole by the mercy of sequence, and as you listen in this quiet moment, carried forward by a mind that remembers behind and imagines ahead, consider the possibility that past and future are not enemies separated by a magical wall. They may be two directions in a deeper landscape, while you are the traveler whose lantern makes one step at a time feel like destiny unfolding. Black holes turn time into something almost unrecognizable. At the edge of a black hole, time stops behaving like the quiet background of life and becomes something closer to a trapdoor. From far away, a black hole may look like a region of darkness surrounded by violent light, but its deepest strangeness is not only that it pulls matter inward. It is that gravity there becomes so intense that time itself is distorted almost beyond ordinary understanding. Around any massive object, time runs a little differently, but near a black hole this effect becomes extreme. Imagine watching an astronaut fall toward the event horizon, the invisible boundary beyond which escape is no longer possible. From your distant point of view, you would never see them simply pass through and vanish in an ordinary way. Their motion would appear to slow. Their signals would stretch. The light coming from them would become redder and weaker, fading as if the universe were dimming their existence frame by frame. It would look as though they were approaching the edge forever, never quite crossing it. But from the astronaut's own experience, if the black hole were large enough to avoid immediate destruction by tidal forces, they could pass the event horizon without feeling a sudden wall or surface. There would be no glowing line in space, no dramatic doorway announcing that the rules had changed. Locally, their watch would still tick normally. Their heart would still beat normally. The terrifying part is that the change is not in how time feels from inside, but in what the future becomes. Once inside the event horizon, all possible paths forward point deeper inward. Escaping is not just difficult. It is like trying to walk into yesterday. The center is not merely a place waiting ahead in space. In a strange sense, it becomes part of every possible future for anything that has crossed the boundary. This is why black holes make time almost unrecognizable. Outside, you can choose directions. You can move away from a star, circle a planet, turn around, return home. Inside a black hole, the structure of space-time itself has tilted so severely that moving forward in time means moving toward the interior. The future narrows, freedom becomes geometry, and yet the black hole does not need to suck like a vacuum cleaner to do this. Far enough away, its gravity behaves like the gravity of any object with the same mass. If the sun could somehow become a black hole with the same mass, Earth would not instantly be swallowed. It would keep orbiting the same mass, though of course losing sunlight would destroy life. The true danger lies close to the horizon, where escape speed reaches the speed of light, and closer still, where tidal forces can stretch objects because gravity pulls harder on the nearer side than the farther side. Near smaller black holes, this stretching could tear matter apart violently. Near supermassive black holes, the horizon can be so wide that crossing it might feel deceptively calm at first, like drifting past a point of no return in total silence. Around black holes, matter can also form blazing accretion disks, heating to enormous temperatures as gas spirals inward, releasing more energy than many stars. Light can bend around the black hole, and in some regions photons can orbit briefly, turning space into a warped hall of impossible paths. But the center remains hidden behind the horizon. Our current theories predict a singularity, a place where density and curvature become extreme. Yet most physicists believe this signals that our theories are incomplete. We do not yet know what truly happens at the deepest core. That uncertainty matters. It keeps black holes from becoming fantasy monsters and makes them something more powerful. Real objects where our understanding of time, gravity, and information reaches its limit. So when you think of a black hole, do not imagine only a cosmic drain. Imagine a place where the future bends inward, where distant observers and falling travelers disagree in hauntingly different but scientifically meaningful ways, where light itself struggles to carry news back out, and where time is no longer the gentle river you know. A black hole is not just darkness. It is a region where the universe teaches you that time is not guaranteed to remain familiar. And perhaps that is why it unsettles us so deeply. Because near a black hole, the thing we trust most, the forward motion of existence, becomes part of the mystery. Space can expand faster than light without breaking physics. The universe can separate two galaxies faster than light and still not break the rule that nothing can outrun light through space. That sounds like a contradiction, but it is one of the clearest places where human intuition fails. Because we imagine space as an empty stage where objects move around, as if galaxies were ships crossing a dark ocean. In that picture, the speed of light is the ultimate speed limit, so anything faster than light sounds impossible. But cosmic expansion is not ordinary motion through space. It is the stretching of space itself. A distant galaxy is not necessarily flying away from us like a rocket breaking the laws of physics. Instead, the distance between us and that galaxy is growing because the fabric of the universe is expanding between the galaxies. Locally, nothing is being pushed past light speed. A spaceship, a particle, a signal, a beam of light, all of these still obey the same local rule. But when enough space lies between two very distant regions, and all of that space is stretching, the total separation can grow faster than light would travel across that same distance. The easiest way to feel this is to imagine dots on the surface of an inflating balloon. The dots are not crawling across the rubber, yet the distance between faraway dots increases as the surface stretches. Now imagine that idea without an outside room, without a center on the surface, and without a balloon wall you could step away from. That is closer to what cosmic expansion means. Space is not expanding into a pre-existing emptiness like smoke filling a room. The distances within space are changing. Astronomers see this through redshift, the stretching of light from distant galaxies. As space expands while light travels, the light's wavelength gets stretched too, shifting it toward the redder side of the spectrum. The farther a galaxy is, the more expansion its light has usually crossed, and the stronger this stretching can be. This is not just a visual effect or a trick of observation. It is one of the main pieces of evidence that the universe is expanding. But there is an important detail. Expansion does not tear apart everything equally. Your body is not expanding. The Earth is not expanding. The solar system is not expanding. Even galaxies and galaxy clusters can remain held together by gravity. Cosmic expansion becomes dominant across enormous distances, where gravity has not bound structures into stable systems. It is a large-scale property of the universe, not a force making your room slowly grow. And this makes the truth even stranger, because the universe is not simply a collection of objects moving through a fixed container. The container itself has history. It can stretch, it can cool, it can carry ancient light across billions of years while changing the light along the way. In the earliest moments after the Big Bang, cosmologists think the universe may have gone through an extremely rapid expansion called inflation, where space expanded at a staggering rate. This did not mean particles were racing through space faster than light like tiny bullets. It meant the scale of space itself changed incredibly quickly. Later, the expansion slowed and evolved, and today it is accelerating again on the largest scales. A behavior linked to what scientists call dark energy, though its true nature remains one of the biggest unsolved mysteries in physics. So when you hear that space can expand faster than light, do not imagine the universe committing a crime against its own laws. Imagine instead that the law was never about the stretching of all space at once. The speed of light limits how fast information, matter, and influence can move locally through space-time. It does not place a simple ceiling on how quickly the distance between two very remote regions can grow when the geometry between them changes. This is why the phrase feels almost impossible. Your mind is trying to apply everyday motion to something deeper than motion. A road can lengthen, while two travelers on it obey every speed limit. A map can stretch while no city runs across the paper. And the universe, in its quiet vastness, can carry galaxies away from one another, not by launching them through darkness, but by making more distance appear between them. The result is both beautiful and unsettling. Some light reaches us only after being stretched by the growth of space for almost the entire age of the cosmos. Some regions are receding so quickly because of expansion that messages sent from here today may never catch them. Not because light has become weak, not because physics has failed, but because the space between here and there keeps growing too much for contact to overcome. So the next time you imagine the universe, do not picture a static emptiness with objects scattered inside it. Picture something alive in structure, a deep and evolving geometry where distance itself can change. Space is not merely where reality happens. Space is one of the things happening. There may be galaxies we will never reach, even with infinite patience. The most heartbreaking border in the universe is not a wall, a black hole, or the edge of space, but a distance that grows faster than any journey can defeat. Somewhere out beyond the galaxies we can map, there are islands of stars that may exist, shine, collide, form planets, and carry their own long histories. Yet no traveler from Earth could ever reach them, not because we lack patience, courage, or imagination, but because the universe itself keeps changing the distance between here and there. This is one of the hardest truths to feel. Seeing a galaxy does not always mean it is reachable. Light from many distant galaxies began its trip toward us long ago, when those galaxies were closer and the universe was younger. That ancient light can still arrive, slipping through the growing darkness like a message sent before the door began closing. But if we tried to leave today and chase the source, even with a ship moving as close to light speed as physics allows, some destinations would remain forever beyond contact. The reason is not that the galaxies are speeding through space like rockets outrunning us. It is that space between the galaxies is expanding, and across enormous distances, that expansion can add new separation faster than any signal or spacecraft can overcome. Imagine trying to walk toward a mountain while the ground between you and the mountain keeps stretching. You may move forward with perfect effort, but the path itself grows faster than your progress. In ordinary life, roads do not behave this way, so the mind resists the idea. But on cosmic scales, distance is not a passive emptiness. It has history. It evolves. It can carry objects apart until their futures no longer overlap. This creates what cosmologists call a cosmic event horizon, a boundary not made of matter, but of possibility. Beyond it, light emitted now may never reach us, no matter how long the universe continues. And if light cannot make the journey, no message, no ship, no signal, and no civilization moving within the rules of physics can make it either. This means the universe is not only vast, it is becoming more separated with time. There are galaxies whose old light we can study today, while their present and future are already slipping away from us permanently. They are visible as history, but unreachable as places. That distinction is quietly devastating. A telescope can show you a galaxy as it was, but no engine can promise you its future. The sky is therefore not just a map of destinations, it is also a map of losses. Some of the lights we see are like letters from cities we can never visit, written before the bridges burned. And this is not a failure of technology waiting to be solved by a more advanced age. It comes from the structure of space-time itself and the accelerating expansion of the cosmos. Even a civilization far older than ours, with patience measured in millions of years, would still face horizons. There are limits that intelligence cannot negotiate with, because they are not political, mechanical, or psychological. They are built into the geometry of reality. Yet this truth also makes our local cosmic neighborhood feel more precious. The Milky Way, Andromeda, and nearby galaxies bound by gravity belong to a region that can remain connected while the larger universe drifts away. In the very far future, if expansion continues as current evidence suggests, distant galaxies may fade from view so completely that future observers could see a much emptier sky and have far less evidence of the wider cosmos. They might live inside a universe that appears smaller than ours, not because the universe shrank, but because its distant lights became unreachable and invisible. We are living during an era when the cosmos still reveals much of its larger story. That is a privilege hidden inside the darkness. So when you hear that there may be galaxies we will never reach, do not imagine a simple travel problem. Imagine existence divided by horizons of contact, with whole realms of stars becoming untouchable not through violence, but through distance patiently multiplied by time. The universe is not only expanding outward, it is quietly deciding what can still belong to our future. And perhaps that is what makes the thought so haunting. Some places are real, some places are luminous, some places may be filled with worlds. But reality does not promise that everything real can be reached. Some doors are open only to light from the past, and by the time you see them, the way forward has already closed. The universe has no center, but every point looks like the center. The universe has no throne room, no middle point, no hidden cosmic capital from which everything else is moving away. That may sound strange, because when people hear that the universe is expanding, they often imagine an explosion, matter blasting outward from one central location into a vast empty darkness, with galaxies flying like sparks from a firework. But that picture is deeply misleading. The Big Bang was not an explosion from a point inside space. It was the early hot, dense state of space itself. There was no empty arena waiting outside it, no central coordinate where the universe began while everything else rushed away. Instead, as far as our observations can tell, the large-scale universe expands everywhere. Distances between faraway galaxy clusters grow because the structure of space changes, not because all galaxies are fleeing from a single middle. And this creates one of the most mind-bending truths in cosmology. Wherever you are, if you look far enough, it can feel as if you are at the center. From Earth, distant galaxies appear to be receding in every direction. The farther they are, the more their light is stretched by cosmic expansion. It is tempting to think, then we must be near the center. But an observer in one of those distant galaxies would see something similar from their own sky. They would look around and find other galaxies receding from them too, not because every location is secretly the one true center, but because expansion has no preferred center within the universe. It is more like the distances in the whole cosmic pattern are growing. So every observer sees remote regions moving away from their own point of view. A useful way to picture this is rising bread dough filled with raisins. As the dough expands, every raisin sees other raisins getting farther away. No raisin has to be the center of the dough's expansion for the effect to happen. The analogy is imperfect because the real universe is not dough sitting inside a kitchen, but it helps remove the false image of a blast from one location. The deeper idea is that center may be the wrong question. A center belongs to an object sitting inside a larger space, but if space itself is the thing being described, then asking where its center is can become like asking where the center of Earth's surface is. On the surface alone, every point can be treated equally. There is no special surface point that all others orbit around. The universe may be finite or infinite. Scientists do not know for certain. But in either case, our best models do not require a central point in space. What we do have is the center of our observable universe. And that is different. Because light takes time to travel, and the universe has a finite age, we can only see a limited region around us. A cosmic bubble defined by what light has had time to reach us. Naturally, we sit at the center of that observable bubble, just as you stand at the center of your own horizon when you look across the ocean. But your horizon does not make you the center of Earth. It only marks the limit of what you can see from where you are. In the same way, our observable universe is centered on us because observation is centered on the observer, not because the entire cosmos revolves around Earth. Another civilization far away would have its own observable universe centered on itself, overlapping with ours in some regions and extending into areas we may never see. This is humbling in a very precise way. The universe does not single us out, yet our view naturally places us in the middle of what we can measure. We are central to our own evidence, but not central to existence. The sky gives us a perspective that feels privileged, while science gently removes the privilege from the interpretation. And maybe this is one of the great emotional lessons of cosmology. Your viewpoint matters deeply, but it is not the whole. Every observer carries a circle of visibility around them. Every world, every galaxy, every possible watcher looks outward from its own local center and mistakes, perhaps for a moment, perspective for importance. But the cosmos is larger and quieter than that. It does not need a center to have order. It does not need a throne to have structure. It can be centerless and still lawful, immense and still coherent, without placing any single point above the rest. So when you look into the night and feel that everything surrounds you, you are not entirely wrong. The observable universe does surround you. Your horizon is yours. Your sky is yours. But beyond that horizon, there may be other skies with their own centers, their own limits, their own observers wondering the same thing. And in that thought, the universe becomes less like a kingdom with a capital and more like an endless field of perspectives. Each one real, each one partial, each one looking outward from its own small candle of awareness. Most of the universe is invisible, missing, or unreachable. Almost everything that shapes the universe is either unseen, unknown, or forever beyond your reach. You look up and see stars, galaxies, glowing nebulae, scattered points of light, and it feels as if the cosmos is revealing itself generously, as if darkness is just the background and the shining things are the main story. But modern astronomy has discovered something far more unsettling. The visible universe is only the surface foam of a much deeper ocean, All the ordinary matter we know, stars, planets, gas clouds, dust, oceans, mountains, bodies, blood, and every atom that makes up every living thing, accounts for only a small fraction of the universe's total contents. Most of what exists does not shine, does not reflect light, and does not announce itself directly to human eyes or telescopes. Dark matter, for example, has never been seen in the ordinary way, yet its gravitational fingerprints appear across the cosmos. Galaxies spin too quickly for their visible matter alone to hold them together. Light from distant objects bends as it passes through regions where unseen mass must be present. The large-scale structure of the universe, the web-like arrangement of galaxies across immense distances, makes far more sense when dark matter is included. It is not called dark because it is evil or mystical. It is called dark because it does not interact with light in the familiar way. It is like an invisible scaffolding around the luminous universe, shaping where galaxies form while refusing to become visible itself. And then there is dark energy, an even stranger name for an even deeper ignorance. Astronomers discovered that the expansion of the universe is not simply continuing. On the larger scales, it is accelerating. Something associated with space itself appears to be driving galaxies farther apart over time, yet no one fully knows what it is. Dark energy is not a solved object sitting neatly in a cosmic catalogue. It is a label for a real effect we can measure but not yet truly explain. So the universe is not merely full of things we cannot see. It is governed in part by things we do not understand. And even within ordinary matter, much of it is not arranged in beautiful stars. A great deal of normal matter exists as thin gas between galaxies. Faint, diffuse, and difficult to detect, spread through cosmic space like a nearly invisible mist. The shining parts are dramatic, but they are not the majority. The universe is quieter, colder, dimmer, and more hidden than the night sky suggests. And beyond the invisible comes the unreachable. There are regions so far away that their light has not had time to reach us since the beginning of the cosmos. They may exist, they may contain galaxies, stars, planets, and histories, but they lie outside our observable universe, not because they are imaginary, and not because they are blocked by a wall, but because information from them has not reached us, and may never reach us. The observable universe is not the whole universe. It is only the portion from which light has had enough time to arrive. This means our cosmic map is not a map of all existence. It is a map of our horizon, and a horizon can feel like an edge even when it is only the limit of your view. This should change how you think about knowledge. Human beings have built powerful telescopes, particle detectors, space observatories, and mathematical models, and still the larger picture remains mostly hidden. We are not ignorant because we have failed to look. We are limited because reality is larger than visibility, larger than reach, larger than the senses and instruments we currently possess. Yet there is something beautiful in this limitation. The universe gives clues. It lets invisible matter reveal itself through gravity. It lets dark energy reveal itself through expansion. It lets ancient light reveal the early cosmos. It lets absence become evidence. Science at its best is the art of listening to what cannot speak directly. It studies shadows, distortions, patterns, motions, and gaps, then asks what unseen truth must be present for those signs to exist. So when you look at the sky and feel small, understand that the smallness is not only about size, it is about access. You are seeing a luminous fraction of a reality mostly hidden behind darkness, distance, and mystery. The stars are not the universe exposing itself completely. They are the visible hints of something far larger. And perhaps the deepest lesson is this: existence does not owe you visibility. Some things can be real without shining. Some truths can shape your life without ever entering your eyes. Some parts of the cosmos may remain beyond every journey, every signal, every future attempt to know them. Still, from this tiny island of awareness, you can notice the clues. You can measure the pull of what cannot be seen. Particles may not exist until reality is forced to answer. A particle is not always a tiny bead waiting patiently in the dark with a fixed address, a fixed path, and a complete set of answers already written inside it. That is the strange doorway quantum physics opens, and it is easy to misunderstand. In daily life, an object can be hidden without becoming uncertain in any deep way. A coin under a cup is still either heads or tails, even before you look. A key lost in a room still has a location, even if you do not know where it is. Ordinary ignorance means the answer exists, but you have not found it yet. Quantum uncertainty is more unsettling than that. For very small things like electrons or photons, nature does not always seem to keep every property sharply defined before a measurement happens. The particle is not simply hiding a clean answer from you. In many situations, it is described by a spread of possibilities, a set of potential outcomes that only becomes one definite result when the particle interacts with something in a way that leaves a record. This record does not need a human eye or a conscious mind. A detector, a screen, a photographic plate, a bubble chamber, or even the surrounding environment can force the question. Measurement is not magic attention. It is a physical encounter that makes one outcome become real enough to be registered. Before that encounter, the particle can behave less like a miniature object and more like a cloud of chances. Not because scientists are being poetic, but because experiments keep showing that the old picture of tiny solid things moving along hidden tracks does not fully work. In the double-slit experiment, for example, single particles sent one at a time can build up a pattern that suggests wave-like possibility, as though the setup itself matters more than any simple path you imagine. But when the experiment is changed, so the path information becomes available, the pattern changes. Reality answers differently, depending on what kind of question the experiment physically asks. This does not mean particles are imaginary before measurement. It means their properties may not exist in the familiar, fully settled way your intuition expects. The particle is real, but its where, its which way, or its exact measurable state may not be a completed fact until an interaction pins it down. That is why quantum physics feels so different from ordinary uncertainty. It replaces the comforting idea of hidden answers with something more delicate, a world where possibility is part of the machinery, not just a gap in human knowledge. And yet this uncertainty is not chaos. Quantum theory predicts probabilities with extraordinary accuracy. It does not tell you exactly which single outcome will happen in every case, but it tells you the pattern that many outcomes will form over time. This is how something deeply uncertain can still be scientifically powerful. Lasers, semiconductors, medical imaging, and modern electronics all rely on the quantum behavior of matter. The strangeness is not decoration. It is built into the technologies surrounding your life. Still, the philosophical shock remains. At the deepest levels we can test, reality does not seem to be made only of finished facts waiting in silence. It seems to include questions, interactions, and outcomes that become definite only when the world is forced to answer. So when you imagine a particle, do not picture a tiny planet orbiting in darkness, carrying all its secrets in miniature form. Picture something quieter and stranger, a real physical system suspended among possible ways it could appear, until contact with the world turns possibility into evidence. And maybe that is why quantum physics feels so haunting. It suggests that the universe is not only a collection of things, but also a process of becoming definite. Some facts are not merely discovered. They are born at the moment reality is asked the right kind of question. A quantum object can act like it took every possible path. A quantum object can behave as if the universe lets it explore a whole maze of possibilities before one result appears in your world. In ordinary life, a moving thing seems to choose one route. A thrown stone follows one arc. A car takes one road. A raindrop slides down one path on a window. But at the quantum scale, nature does not always work like a tiny version of everyday motion. One of Richard Feynman's most powerful ideas was that to understand a quantum particle, you should not imagine it simply traveling along one clean track from beginning to end. Instead, the calculation treats every possible route as contributing to what finally happens. Some possible paths are direct. Some are strange. Some are longer, curved, delayed, or wildly unlikely. The particle is not a little insect consciously trying every road. And it is not correct to picture a tiny ball literally driving through the entire universe at once in a human way. The deeper truth is subtler. Quantum behavior is described by adding together possibilities, and those possibilities can reinforce one another or cancel one another out before a final outcome is detected. This is why light and matter can produce interference patterns, even when particles arrive one at a time. It is not just that we do not know the path. The experiment itself reveals that the old idea of one hidden, definite route is often too simple. Reality at that scale seems to keep multiple possibilities alive in the structure of the event until interaction forces a definite result. You can think of it like many faint whispers entering a room, some blending into a louder voice, others cancelling into silence until only one clear sound reaches you. The final particle mark on a detector may look simple, one dot, one place, one registered fact. But behind that simplicity is a hidden architecture of possible histories. This is one reason quantum physics is so hard to translate into ordinary language. Our minds evolved to track animals, tools, faces, and falling objects, not clouds of possibility. We want a particle to be a miniature stone. We want it to have a route even when we are not watching. But experiments with electrons, photons, and atoms keep showing that the world underneath familiar reality is not built from small versions of familiar objects. It is built from patterns of probability that only become ordinary looking when they are measured, amplified, and brought into the large-scale world. And this idea is not just strange philosophy. It helps explain real technologies and real phenomena. How electrons behave in atoms, how light moves through materials, how quantum devices work, why certain outcomes are likely and others nearly vanish. The invisible sum of possible paths is part of the machinery behind chemistry, electronics, and the stability of matter itself. Still, the emotional shock remains. If a particle can act as though all routes matter before one route becomes visible, then the universe is not merely a stage where finished things march along finished roads. It is more like a deep field of unrealized alternatives, where what becomes actual is shaped by the way possibilities combine. This does not mean your life choices are literally quantum particles, or that wishing can bend physics into whatever you want. That would be a false and careless leap. But it does offer a powerful lesson in humility. The everyday world you trust is the surface of a stranger order. Beneath the path you finally see may be a silent crowd of paths that never became visible, yet still helped shape the result. So when you look at a beam of light crossing a room, or a shadow forming at the edge of a wall, remember that the clean line your eyes understand is only the final face of a deeper process. Reality does not always begin with one path. Sometimes it begins with possibility itself, and only later does the universe allow one trace to remain. Observation can decide what kind of reality appears. The question you ask a quantum system can change the kind of answer reality is allowed to give. This does not mean the universe obeys your thoughts, or that human consciousness magically creates matter. But it does mean something almost as strange. In the quantum world, the design of an experiment can determine whether nature reveals one face or another. Light, for example, can behave like a wave in some situations, and like a particle in others. Electrons can also show wave-like patterns under certain conditions, even though we often imagine them as tiny bits of matter. The unsettling part is that these are not just two different human descriptions of the same obvious thing. They are two different kinds of behavior that appear depending on how the system is tested. If an experiment is arranged to reveal an interference pattern, the quantum object can behave in a wave-like way, spreading possibility across the setup. If the experiment is arranged to identify which path it took, that wave-like pattern can disappear, and the result becomes more particle-like, more definite, more localized. Reality seems to answer in the language of the question. This principle is often called complementarity. Some properties cannot be fully revealed together in the same experimental situation. You can set up nature to show you one aspect, or you can set it up to show another, but not always both at once with complete clarity. That is very different from ordinary life. If you place a tennis ball in a room, you assume it has a position, a path, a speed, and a shape, whether or not anyone checks. Measuring one feature does not usually erase another, but quantum objects do not behave like small tennis balls. Their measurable properties are tied to interactions, and the interaction you choose matters. A detector is not a passive witness floating outside the story. It becomes part of the physical situation. It changes what information is available, what can interfere, what can remain uncertain, and what must become definite. This is why the word observation can be misleading. It sounds like simply looking, as if a mind opens its eyes and reality becomes shy. But in physics, observation usually means a physical measurement, a contact, a registration, a trace left in the world. When a detector gathers path information, the system is no longer the same as it was when that information was unavailable. The possible alternatives no longer combine in the same way. It is not that the particle feels watched. It is that the universe has been forced to keep a record, and once a record exists, some kinds of quantum behavior are no longer free to appear. This teaches a deeper lesson about knowledge. To know something is not always to uncover a pre-existing detail without consequence. Sometimes knowing is an intervention. Sometimes the question carves the answer into a particular shape. In the large-scale world, this is usually hidden because objects are constantly interacting with air, light, heat, and their surroundings, which makes them settle into familiar, definite states. But at the smaller scales, where isolation is possible and possibilities can remain delicate, the role of measurement becomes visible. The world does not appear as one simple layer waiting to be photographed. It appears differently depending on what kind of contact you make with it. And this is where quantum physics becomes quietly philosophical without needing exaggeration. It suggests that reality is not only made of things, but also of relationships between things, between systems and measuring devices, between what is allowed to remain uncertain and what is forced to become evidence. You cannot demand every face of nature at once. You receive the face your question makes possible. So when you think about observation, do not imagine a mystical gaze controlling the cosmos. Imagine a lock that changes depending on the key inserted. A dark room where opening one door closes another. A world where information is never free from the way it is obtained. And maybe that is the haunting truth. Reality does not always show you what it is in one final, complete form. Sometimes it shows you what can appear under the conditions you create. And every answer carries the shadow of the question that brought it into being. Two particles can behave like one system across space. Two particles can be separated by oceans, planets, or even the width of space, and still behave as if distance is not the deepest thing between them. This is the strange reality of quantum entanglement, one of the most tested and unsettling ideas in modern physics. It begins when two particles interact in a way that links their properties, so that they can no longer be fully described as separate little objects with independent stories. Instead, they become parts of one shared quantum state. If you later measure one of them, the result you find is connected with the result you will find for the other, even if the two particles are far apart. This does not mean one particle sends a secret message to the other faster than light. That is the common misunderstanding, and it matters to avoid it. Entanglement cannot be used to send usable information instantly across the universe, because the result of each single measurement is still unpredictable. But when scientists compare the results afterward, they find patterns of correlation stronger than anything classical physics expected. This is why Einstein found the idea so disturbing and famously resisted it. He believed there might be hidden details carried by the particles from the beginning, like sealed instructions telling each one how to respond later. But experiments inspired by physicist John Bell showed that the universe does not seem to work like that in any simple local way. The correlations are real, and they force us to give up the comfortable image of a world made only from separate parts carrying private instructions through space. Entanglement suggests that at the quantum level, the whole can be more basic than the pieces. Two particles may be far apart in ordinary distance, yet their description remains joined, as if separation in space does not fully erase the relationship created between them. This is not poetry pretending to be science. Entanglement is used in real research and emerging technologies, including quantum communication, quantum computing, and extremely sensitive measurement systems. It is also one reason physicists think information may be a deeper part of reality than ordinary objects appear to show. Still, the emotional shock is hard to avoid. You were taught to imagine the universe as a collection of things. Here is one object, there is another, and between them lies empty space. Entanglement whispers that this picture is incomplete. Sometimes reality is not built from isolated pieces first and connections second. Sometimes the connection is part of what the things are. A pair of entangled particles is not like two coins that secretly decided their outcomes in advance. It is more like a single stretched fact appearing in two places, only becoming fully definite when measured. And yet even that image is imperfect, because quantum reality resists every everyday metaphor we put around it. What we can say honestly is this: nature allows relationships that are deeper than our ordinary idea of distance. The particles do not need to be touching to belong to one mathematical state. They do not need to exchange a signal in the familiar sense to show matching patterns. Their shared history remains written into what can be known about them, and perhaps that is why entanglement feels so haunting. It does not prove that human thoughts are magically connected across space, and it should not be used to dress mystery in false certainty. But it does reveal that the universe is less separable than it looks. At the deepest scales we can test, reality is not always a set of lonely objects drifting through emptiness. It can be a web of correlations, a structure where what happens here and what is found there belong to one larger description. So when you look at the space between things, between stars, between atoms, between one side of the room and another, remember that distance is real, but it may not be final. The world you see is made of separations. The world underneath may also be made of relationships. And somewhere inside that quiet truth, quantum physics asks you to imagine a universe where apart does not always mean alone. Empty space is not empty. It is restless underneath. The emptiest place you can imagine is still not truly still. Remove every planet, every star, every atom, every grain of dust, every drifting molecule, and the space left behind would not become a perfect dead blankness. In modern physics, empty space is not a silent container waiting for things to happen inside it. It is closer to the lowest possible state of fields that exist everywhere. This does not mean space is filled with tiny visible particles popping like sparks in a cartoon, and it does not mean nothing is secretly a magical substance. The truth is more careful and more fascinating. Even when a field has no ordinary particles in it, it can still have unavoidable quantum fluctuations, a kind of restless uncertainty built into the ground level of nature. Think of a perfectly calm sea that can never become mathematically flat, not because wind is blowing over it, but because the sea itself has a built-in tremble at its deepest level. That is how the vacuum begins to change in your mind. It is not emptiness as your senses understand it. It is the lowest energy arrangement nature allows, and even that lowest state is not simple nothing. Scientists can see hints of this hidden restlessness through real effects. One famous example is the Casimir effect, where two extremely close metal plates can feel a tiny attraction because the vacuum fields between and outside them are restricted in different ways. Another is the Lamb shift, a small change in the energy levels of atoms that helped reveal how the quantum vacuum influences matter. Even the way excited atoms release light can be understood partly through their interaction with the surrounding quantum fields. These are not fantasy stories told to make space sound mysterious. They are measurable signs that the vacuum has structure. And yet the word restless must be handled gently. Empty space is not boiling with ordinary matter in a way you could scoop into a jar. Vacuum fluctuations are not little permanent objects appearing from nowhere and breaking the rules. They are features of quantum fields, temporary disturbances in what can be measured, constrained, and predicted. The universe is stranger than common sense, but it is not careless. Its strangeness follows rules. This is what makes the idea so powerful. The background you ignore may be part of the machinery that allows the visible world to exist. Particles are not floating on top of absolute nothing. They are excitations of fields, and those fields do not vanish just because a region looks empty. The silence behind matter still has physical meaning. In laboratories, physicists can even study how changing boundaries or conditions affects the vacuum's behavior, turning what once sounded like pure philosophy into something testable. And on the largest scales, the question of vacuum energy becomes even more haunting, because the energy of empty space may be connected to the accelerating expansion of the universe, though the full explanation remains one of the deepest unsolved problems in physics. So the simple word empty begins to fall apart. A dark room is not empty if radio waves pass through it. Interstellar space is not empty if fields remain there. A vacuum chamber is not absolute nothing if quantum fields still have a ground state inside it. Your intuition was built for air, stone, water, fire, bodies, and surfaces, not for the hidden behavior of fields when everything familiar has been removed. And perhaps that is why this truth feels so quiet and disturbing. It suggests that nothingness may be far harder to achieve than the mind expects. The universe does not easily give you a blank page, even when matter is gone, even when light is absent, even when silence seems complete. The foundations underneath may still quiver with possibility. So when you look into darkness and think there is nothing there, remember that your eyes are not judges of emptiness. They only report what they can receive. Beneath the calm face of space, reality may still be breathing in its smallest permitted way. And maybe the deepest lesson is this: the universe does not need visible things to be active. Even absence has texture, even silence has physics, even empty space, when you look closely enough, is not sleeping. Matter may be only ripples in invisible fields. The solid world may be made of disturbances in something you cannot see. A stone in your hand feels like a hard object, a piece of matter with clear edges and stubborn weight. But modern physics suggests that matter is not best understood as tiny pellets sitting inside empty space. At the deepest level we can describe with our best theories, what we call particles are more like localized excitations of fields that exist throughout space. An electron is not simply a miniature ball hiding inside an atom. It is a stable ripple in the electron field. A photon is a ripple of the electromagnetic field. Other particles belong to their own fields as well, and the visible world appears when these fields interact in structured, repeatable ways. This is difficult to picture because your senses were built for tables, skin, water, tools, and faces, not invisible fields spread across the universe. But think of the surface of a lake. If you see a wave moving across it, you might focus on the wave as if it were a separate thing. Yet the wave is not made of some substance different from the lake. It is a pattern in the lake, a shape of motion carried by something deeper. In a similar but far more precise way, particles may be patterns in underlying fields. They can appear, vanish, transform, or interact, but the field is the more basic stage. This changes the feeling of matter completely. The chair beneath you, the air around you, your bones, your blood, your eyes, and the neurons listening to these words are not built from tiny solid bricks in the simple childhood sense. They are built from excitations, interactions, and stable arrangements of quantum fields. Solidity itself becomes a large-scale effect. When your hand presses against a table, the atoms in your hand and the atoms in the table do not merge into one another because electromagnetic forces and quantum rules resist that overlap. What you feel as hardness is not absolute contact between tiny marbles, but a structured resistance created by fields and particles obeying their rules. Even mass has a deeper story. Some of the mass of familiar matter comes from the energy of particles and fields inside atoms, especially the intense activity binding quarks together inside protons and neutrons. The Higgs field also plays an important role by giving certain fundamental particles their rest mass through interaction with it. So the weight of the world is not as simple as stuff being stuff. It is process, relationship, energy, and field behavior becoming stable enough to feel ordinary. And this is the strange genius of nature. Invisible fields can produce visible mountains. Abstract excitations can become warm hands. Mathematical patterns can become bread, rain, metal, breath, and skin. None of this means matter is fake. A ripple is real. A wave can knock down a wall. A vibration can break glass. A field excitation can build a star. The point is not that the world is less real, but that reality is less like a pile of separate objects than your intuition assumes. Matter may be the music of fields, and particles may be notes that hold their form long enough for atoms to exist, chemistry to unfold, planets to cool, and life to wake up inside the pattern. So when you look at your hand, do not think of it only as flesh arranged in space. Think of it as a temporary harmony of fields, a calm-looking storm of interactions held together for a little while. What you call material is not dead substance. It is activity made durable. It is the invisible becoming touchable. And perhaps that is why the ordinary world feels so mysterious once you look beneath it. Everything that seems solid may be a ripple that learned how to stay. Randomness may be built into the universe at the deepest level. The universe may not be secretly rolling dice because it is confused. It may be doing it because, at the deepest level, certainty is not always available. This is one of the most uncomfortable lessons of quantum physics, because human beings are trained to believe that every event has a complete cause hiding behind it. If a glass falls, something pushed it. If a storm forms, pressure, heat, and moisture shaped it. If a person makes a mistake, we search for reasons in memory, emotion, habit, or circumstance. Even when life feels unpredictable, we often assume the unpredictability comes from missing information. Maybe we do not know enough. Maybe the system is too complicated. Maybe, if we could see every detail, the future would become clear. In many parts of nature, that is true. Weather can feel random, but it follows physical processes so complex that small changes grow into huge differences. A tossed coin looks uncertain, but in principle, its motion depends on force, spin, air, angle, and landing surface. This kind of randomness is practical ignorance. The event is hard to predict, but perhaps the answer was fixed all along. Quantum randomness is different. When an unstable atom decays, current physics does not say there is a tiny hidden clock inside it that secretly chose the exact moment. It gives a probability, a pattern that becomes reliable across many atoms, while the timing of one individual decay remains fundamentally unpredictable in the standard interpretation. One atom may decay soon. Another identical atom may wait much longer. Nothing in their visible sameness tells you which one must go first. The law is precise, but the single outcome is not predetermined in the familiar way. This is not laziness in science. Quantum theory is one of the most successful frameworks ever created, and its probabilities match experiments with astonishing accuracy. The strange part is that the accuracy is statistical. It predicts the shape of many events, not always the destiny of one. Radioactive decay, the detection of a photon, the result of certain particle measurements. These can appear as individual outcomes without a deeper accessible reason deciding exactly which one occurs. Some interpretations of quantum mechanics try to preserve determinism in different ways, and physicists still debate what the theory really means. But experiments have strongly challenged the simplest idea that particles merely carry local hidden instructions waiting to be uncovered. Nature does not seem to be hiding certainty in the ordinary place we expected to find it. And this changes the emotional texture of reality. Randomness in this sense is not chaos spilling everywhere. It is not the universe becoming meaningless. It is constrained uncertainty. It follows rules. It has boundaries. It produces stable patterns from unpredictable events, like rain on a lake forming no chosen drop pattern, yet still obeying gravity, surface tension, and weather. This is why the world can be reliable even if its foundations contain chance. Atoms can form stable matter. Stars can burn. Chemistry can build life. Your body can exist. But underneath the large structures, some individual events may not be scripted in advance. The future is not simply unknown to you. In some cases, it may be genuinely open until nature resolves it. Modern technology quietly uses this. Quantum random number generators can draw randomness from physical quantum processes rather than from ordinary computer algorithms. In laboratories, scientists can build experiments where single events are impossible to predict individually, yet the overall pattern is clear. This is a strange kind of order. Not the order of a machine with every gear already set, but the order of a world where probabilities are part of the law. And perhaps this is why quantum randomness feels both frightening and liberating. It removes the old comfort of a perfectly clockwork universe, but it also removes the suffocation of a universe where every detail was already silently decided. It suggests that reality may not be a finished script playing out line by line. It may be a lawful unfolding where chance has a real seat at the table. Still, we must be careful. Quantum randomness does not mean your thoughts can magically force outcomes, and it does not make every mystery spiritual. It simply means that at small scales, nature behaves in a way that does not fit the old dream of perfect predictability. So when you hear the word random, do not imagine nonsense. Imagine a deeper kind of uncertainty, disciplined by mathematics, tested by experiment, and woven into the behavior of matter itself. The universe may be less like a clock and more like a song where some notes are chosen only as they are played. And from those uncertain notes, somehow the steady music of stars, atoms, bodies, and consciousness begins. The vacuum may contain more activity than nothing should allow. Nothing may be one of the most misleading words the human mind ever invented. You picture the vacuum as a perfect absence, a blank stage after every object has been removed, a place where nothing pushes, nothing flickers, nothing waits. But physics has slowly forced us to treat the vacuum with far more caution. In ordinary language, a vacuum means empty space. But in modern physics, it means something closer to the lowest possible state of a system. And the lowest possible state is not the same as absolute non-existence. Even when there are no ordinary particles present, the underlying fields of nature still remain. And because quantum systems cannot be perfectly frozen into absolute stillness, the vacuum can carry subtle activity. This activity is not like dust floating in air, and it is not a swarm of tiny objects magically appearing for free. It is more like hidden tension in the rules of reality, a background uncertainty that shows itself only through its effects. One of the most fascinating examples is vacuum polarization. Near a charged particle, the vacuum does not behave like a simple dead emptiness. Quantum fields respond in a way that slightly changes how the charge is experienced. It is as if the space around the particle is not a passive void, but a medium whose invisible structure can be disturbed. In extremely powerful fields, physicists predict that enough energy could even turn what looks like empty space into real particle-antiparticle pairs. Not because matter comes from nothing without cost, but because energy is being supplied to make the vacuum unstable in a measurable way. This idea, known in physics through the Schwinger effect, shows how deeply the vacuum is tied to the possibility of matter. Space is not a box where particles simply sit. It is part of the machinery that allows particles to appear under the right conditions. And near black holes, the story becomes even stranger. Quantum fields around an event horizon can lead to Hawking radiation, a faint theoretical glow that suggests black holes are not completely black and may slowly lose energy over immense time. The details are subtle, but the lesson is powerful. What counts as empty can depend on fields, gravity, energy, and even the observer's situation. There is also the Unruh effect, another strange prediction, where an accelerating observer may describe the vacuum differently from someone who is not accelerating. This does not mean reality is fake or that anything can be anything. It means the vacuum is not a simple universal nothingness that everyone must experience in the same way. It has structure tied to motion, measurement, and the deeper rules of quantum theory. Even in laboratories, achieving a perfect vacuum is impossible in the everyday sense. Scientists can remove enormous numbers of particles from a chamber, lowering the pressure until it becomes emptier than any natural environment on Earth. but they still do not remove the fields themselves, and they do not erase quantum behavior. The word empty becomes a practical term, not an absolute one, and this should make you reconsider the silence between things. The gap between atoms is not a lifeless hole. The darkness between stars is not pure non-being. The vacuum is not a dead absence beneath reality. It is closer to the quiet floor from which physical possibilities rise. Most of the time, it stays calm enough for the universe to look stable. Tables remain tables. Stars remain stars. Your body does not dissolve into chaos, but beneath that calm is a restless foundation, constrained by laws, full of potential, never quite becoming the philosophical nothing your imagination expects. Perhaps that is the deepest surprise. Nature may not allow perfect emptiness in the way the mind desires. The universe seems to prefer a kind of structured silence, a silence with rules, tensions, and hidden responses. So when you think of nothing, do not imagine a blank page untouched by existence. Imagine instead a page so dark and still that it looks empty from far away, while underneath the paper, invisible ink is already waiting for the right pressure to appear. The vacuum may contain more activity than nothing should allow, because it was never truly nothing at all. It is the quiet, restless underside of reality, where absence becomes a state, and even silence has something to say. The laws of physics may be rules for information, not objects. Maybe the universe is not built first from objects, but from rules about what can be known, changed, copied, hidden, and preserved. This idea sounds abstract at first because your senses present reality as a collection of things: stones, stars, bodies, atoms, light, air, heat, motion. You naturally imagine physics as the study of objects and what those objects do. But the deeper modern view is more subtle. A physical object is not just stuff sitting there. It is a state carrying information. Where it is, how it moves, what energy it has, how it can interact, what histories it can leave behind. All of this is information arranged in physical form. When a scientist describes a system, they are not only describing a thing. They are describing the possible answers that thing can give when nature is questioned. In this sense, the laws of physics may be less like commands shouted at matter and more like rules limiting how information can transform. Energy conservation, for example, is not merely a rule about fuel and motion. It tells us that certain quantities cannot simply vanish from the accounting of reality. Momentum conservation says something similar about motion across interactions. Entropy, often described as disorder, can also be understood as a measure of how many hidden arrangements could produce the same visible condition. A warm cup cooling in a room is not just heat spreading, it is information about the original concentrated warmth becoming harder to recover, scattered into countless microscopic details. The world does not forget in a human way, but it can make information practically unreachable. Even computation is physical. When a computer erases information, it is not doing something outside nature. There is a real energetic cost tied to that act. Thought, memory, digital storage, measurement, and communication all require physical systems. Information is not a ghost floating above matter. It must be carried by something. A voltage, a magnetic mark, a pattern of molecules, a beam of light, a neural connection. But once you understand that matter carries information, the boundary begins to blur. A particle's identity is not like a tiny name tag attached to a miniature object. It is defined by properties, interactions, and the rules it obeys. In quantum physics, this becomes even more striking. Information cannot always be copied perfectly, and measurement can change what can be known. The universe seems careful about information in ways that ordinary intuition would never expect. You can move it, encode it, scramble it, protect it, or lose access to it, but you cannot treat it as meaningless decoration. Some physicists have even suggested that reality itself may be deeply informational, not in the sense that we are definitely inside a computer simulation, but in the sense that physical law often behaves like a structure of allowed and forbidden information changes. What can be distinguished? What can be predicted? What can be reversed? What can leave a record? These questions may be as fundamental as asking what objects exist. And this changes the way the ordinary world feels. A footprint in sand is information about pressure and direction. A fossil is information preserved in stone. DNA is information carried in chemistry, guiding the building of living bodies. A photograph is information trapped in light-sensitive material or digital memory. Your own brain is a living information system, constantly updating a model of the world so you can move through it. Everywhere you look, reality is not only being made of things, it is being made readable, recordable, and transformable. Yet the deepest truth is not that information replaces matter. It is that matter and information may be inseparable, two faces of the same hidden order. A thing is what it is, partly because of the information it carries and the rules that decide how that information can change. So when you touch a table, look at a star, or remember a voice from years ago, you are not encountering dead objects alone. You are encountering patterns that survived, signals that remain stable, arrangements that still answer questions. The universe may be less like a warehouse full of objects and more like a vast grammar, where every particle, field, atom, and mind is a sentence written in physical form. And perhaps that is why reality can be both solid and mysterious. Beneath the things you see may be rules about meaning, memory, difference, and transformation, the quiet language by which the universe keeps track of itself. Reality may be a process that pretends to be a thing. Nothing around you is as still as it pretends to be. A mountain looks like a thing, a tree looks like a thing, your body looks like a thing. Even a quiet stone on the ground seems to possess a simple identity. Here it is, separate, finished, itself. But the deeper you look, the more reality begins to resemble an ongoing activity rather than a collection of frozen objects. A flame is the easiest doorway into this idea. You can point to it and say that flame as if it were one object, but the flame is not a solid item sitting there. It is a process, fuel breaking apart, oxygen reacting, heat rising, light being released, gases flowing, shape changing every moment. It keeps an identity only because the pattern continues. Stop the flow and the flame is gone. The same is true in slower and quieter ways for much of what you call the world. A river has a name, a location, a shape on a map. Yet the water inside it is never the same water. A cloud can look like one soft object in the sky, but it is a temporary arrangement of droplets, temperature, pressure, and air motion. A living body may feel like one stable self wrapped in skin, but it survives through constant exchange, air entering and leaving, blood circulating, cells repairing, proteins being built and broken down, food becoming tissue, waste leaving, heat flowing outward. You are not a statue that happens to breathe. You are a pattern maintained by breathing. Even objects that seem lifeless are less frozen than they appear. The atoms in a table vibrate. The bonds that hold materials together are active relationships, not tiny nails hammered into place. A rock is slowly weathered by water, heat, cold, pressure, and time. A metal beam expands and contracts with temperature. A building that looks solid is constantly resisting gravity, wind, moisture, and decay. Stability is often not the absence of change. It is change organized so well that your senses call it stillness. This matters because the human mind loves nouns. It cuts the world into pieces and names them. Cup, hand, road, star, person, memory, nation, life. Naming is useful. It lets you think, speak, plan, and survive. But sometimes a name makes a process look like a thing. It hides the motion that keeps the thing appearing. A forest is not merely a group of trees. It is sunlight becoming sugar, roots trading nutrients with fungi, water lifting through trunks, leaves breathing with the air, insects feeding, seeds waiting, dead matter returning to soil. A city is not merely buildings. It is traffic, electricity, food supply, language, work, waste, desire, memory, law, and millions of daily choices passing through streets like blood through arteries. Even your personality, which feels like something you have, is partly a process. Habits repeated, emotions regulated, memories updated, relationships reflected back to you. Attention choosing certain paths until they become familiar. The world tricks you because processes that repeat reliably begin to look like objects. A whirlpool has a shape, but you cannot take it out of the water and place it on a shelf. Its identity is the movement. Perhaps many things are like that. They are not illusions, but they are not solid in the way the mind wants them to be. They are temporary agreements between forces, materials, energy, and time. This does not make reality weaker. It makes it more alive. If everything were truly fixed, nothing could grow, heal, adapt, burn, think, remember, or become. The same change that makes things impermanent also makes them possible. A body can recover because it is a process. A mind can learn because it is a process. A relationship can deepen or break because it is a process. Even civilization continues only because people keep renewing it through action, attention, and belief. So when you look at something ordinary tonight, a candle, a wall, your own hand resting quietly, let the stillness become transparent. Beneath the surface, something is happening. Something is being maintained. Something is moving slowly enough to look like a thing. And maybe that is the soft secret of reality. The universe may not be made of finished objects as much as enduring patterns. What you call a thing may be a process that has learned how to last long enough for you to give it a name. Your brain can hide something right in front of you. A person can stand in the center of your vision and still disappear from your mind if your attention is busy somewhere else. This is one of the most unsettling discoveries about human perception because it shows that seeing is not the same as noticing. You may believe that if something is directly in front of you, your brain must register it. But awareness is far more selective than that. Your eyes can receive information while your conscious mind never grants it entry. In famous experiments on inattentional blindness, people asked to focus on a specific task, such as counting passes between basketball players, can fail to notice something as obvious as a person in a gorilla suit walking through the scene. The shocking part is not that people are careless. It is that their brains are doing exactly what attention is designed to do, choosing what matters right now and suppressing the rest. Attention is not a wide floodlight covering reality evenly. It is more like a narrow beam, and whatever falls outside it can become strangely invisible, even when the image enters the eyes. This happens because the brain has limited processing power. At every moment, the world offers too much. Colors, movement, sounds, body sensations, faces, signs, memories, threats, goals, and tiny changes in the environment. If consciousness tried to handle everything equally, you would drown in detail. So the brain filters. It prioritizes the task, the danger, the familiar pattern, the thing you are searching for, the thing your emotions have marked as important. Everything else may be weakened, ignored, or deleted before it becomes part of conscious experience. This is why you can search for your keys while they are lying on the table, miss a friend waving across the street, or fail to notice a major change in a room after looking away for only a moment. Change blindness shows the same weakness from another angle. If your attention is interrupted, large differences can pass unnoticed because your brain does not store a perfect picture of the scene. It stores what seems relevant. It assumes the rest remains stable unless something forces attention back to it. Magicians use this beautifully. They do not need to make objects truly vanish. They only need to guide your attention away at the right moment. Your brain performs the disappearance for them. The hand moves, the eyes follow, the expectation locks onto one place, and the real action happens somewhere else. In daily life, this can be harmless, even funny, but it can also be dangerous. A driver looking for cars may fail to notice a motorcycle. A person staring at a phone can miss a step, a signal, or a face full of emotion. A witness to an event may feel certain they saw everything, while their attention captured only fragments. This is why confidence is not the same as accuracy. You can be completely sure nothing unusual happened simply because your brain never allowed the unusual thing to become conscious. And this does not only apply to objects. You can miss moods in people you love because you are focused on your own worry. You can miss opportunities because your mind is busy confirming an old belief. You can miss beauty because stress has narrowed the world into a problem. Attention does not only select what you see, it shapes the reality you live inside. The world may be rich, but your experienced world is the portion your attention permits. That is both frightening and strangely hopeful. Frightening, because you are not as aware as you feel. Hopeful, because learning to shift attention can reveal layers of life that were always present. A quiet expression, a pattern in your behavior, a sound in the room, a small kindness, a warning sign, a possibility. So when you move through the world, remember that blindness is not always caused by darkness. Sometimes it is caused by focus. Sometimes the thing you cannot see is not hidden behind a wall, but standing in the open, waiting for your mind to make room for it. And maybe the deepest lesson is this: reality is not only what appears before your eyes, it is what survives the gate of attention. The brain protects you by narrowing the flood, but in doing so, it can hide the obvious. To wake up, even slightly, is to realize that the world has always been larger than the part you were looking at. Color may be a private simulation inside your skull. Red is not sitting inside the apple, it is happening inside you. That is the quiet shock hidden inside every color you have ever loved. The world outside your skull contains light, surfaces, and wavelengths, but it does not contain color in the way your experience presents it. A leaf does not carry green as a tiny substance painted onto its atoms. A sunset does not pour orange into the sky like liquid emotion. What happens is more strange and more intimate. Light from the sun or another source strikes objects. Some wavelengths are absorbed, others are reflected, and a portion of that reflected light enters your eyes. Inside the retina, specialized cells respond to different ranges of light, and the brain compares their signals to create the experience you call color. Color is therefore not just received, it is interpreted. It is a private result of biology meeting physics. This is why two lights with different physical mixtures can sometimes look like the same color to you, because your visual system can treat different combinations as equivalent. This is also why screens can create the illusion of millions of colors using only tiny red, green, and blue light sources. They are not recreating the full complexity of natural light. They are carefully stimulating your eyes in ways your brain interprets as color. Your experience is real, but it is not a direct copy of the outside world. It is a translation, and the translation can vary from mind to mind. People with color blindness do not simply miss beauty. They live with a different mapping between light and experience because one or more types of cone response work differently. Some rare people may have an extra kind of cone cell, giving them the possibility of finer distinctions most of us cannot imagine. Even among people with ordinary color vision, no one can step inside another person's mind and confirm that your blue feels exactly like their blue. You can both point to the same sky and agree on the word, but agreement in language is not proof of identical inner experience. This is the mystery philosophers call the private nature of qualia, the felt quality of experience. Science can measure wavelengths, nerve signals, and brain activity, but the actual sensation of red, the warm inward flare of it, exists only where awareness receives it. And your brain does not even assign color mechanically from light alone. It corrects for context. A white shirt can still look white under yellow indoor light or bluish daylight because the brain estimates the lighting and adjusts your perception. This is called color constancy. And without it, the world would become visually unstable every time illumination changed. But the same helpful correction can create illusions. A gray patch may look blue in one setting, yellow in another, dark in shadow, bright in sunlight. The famous disagreements over the color of certain images happen because different brains make different assumptions about the light source. In those moments, you're not just seeing a picture, you are seeing your brain's interpretation of the conditions around the picture. Color becomes a negotiation between light, surface, context, memory, and expectation. That is why color feels so emotionally powerful. It is not merely data. It is the brain turning physics into atmosphere. Red can signal fruit, blood, danger, heat, passion, or warning. Blue can feel cold, distant, calm, or infinite. Green can become life, growth, poison, money, or safety depending on culture and setting. The same physical light can be folded into meaning by the mind. And perhaps this is why a world without color feels almost impossible to imagine. Color is not necessary for objects to exist, but it is deeply tied to how human reality feels alive. It organizes attention. It guides behavior. It marks ripeness, sickness, fire, sky, skin, emotion, and memory. The universe may not be colored in the way you experience it, yet your brain paints it so you can move through it with feeling and understanding. So when you look at a red flower, do not think of red as a simple property sitting quietly on the petals. Think of it as an event. Light leaving the flower, entering your eyes, awakening cells, moving through neural pathways, and becoming a private glow inside consciousness. The color is not only out there, and not only in here, it is born in the meeting, and maybe that is the beauty of it. The world provides the signal, but your mind provides the sunrise. Your inner voice may not be as yours as it feels. The voice in your head feels like the most private thing you own, yet much of it may have been borrowed from the world around you. You hear it when you plan tomorrow, when you silently rehearse an apology, when you criticize yourself after a mistake, when you read words without moving your lips, when you argue with someone who is not even in the room. It feels intimate, almost sacred, as if there is a small speaker hidden inside consciousness saying exactly what you are. But inner speech is not born fully formed. It grows from language, and language comes from outside you before it becomes part of you. As children, we first hear voices from parents, teachers, siblings, strangers, television, stories, warnings, praise, correction, comfort. We speak out loud while learning how to think through problems. Then, over time, some of that speech becomes quieter, shorter, more internal. The child who says, "Don't touch that," or "Put this here," may later become the adult who guides themselves silently through a task. In that sense, your inner voice is not a pure original sound from the center of the soul. It is social speech turned inward, a private echo of public language. This is why the tone of your inner voice can sometimes sound suspiciously like people who shaped you. The harsh sentence you say to yourself may carry the rhythm of an old authority. The comforting phrase that steadies you may have been learned from someone who once made you feel safe. Even your silent thoughts often use words you did not invent, grammar you inherited, metaphors your culture handed down, and categories your language taught you to notice. The mind feels alone, but it speaks with 1,000 fingerprints on its tongue. Neuroscience makes this even stranger. Inner speech can activate some of the same brain systems involved in producing and hearing language, though usually in a quieter, internally controlled way. When you imagine saying something, your brain may prepare parts of the speech system without sending full commands to the mouth. When you silently hear your own thought, auditory regions can participate without outside sound entering the ears. The brain also uses internal monitoring to recognize self-generated mental speech as mine, which helps explain why most inner voice feels self-owned rather than like an external sound. But this ownership is not always perfect. Intrusive thoughts can appear suddenly, unwanted and disturbing, not because they reveal your true self, but because the brain can generate verbal fragments, fears, images, or impulses that do not match your values. A thought appearing in the mind is not the same as a decision, a desire, or a truth. This matters deeply because many people suffer by believing every inner sentence must be a confession. It is not. The mind produces language the way the sky produces weather. Some patterns are useful, some are repetitive, some pass through without needing to be obeyed. Your inner voice can help you plan, remember, solve problems, control impulses, and imagine the future. But it can also trap you in loops. It can turn one awkward moment into a trial. It can replay criticism until it sounds like wisdom. It can narrate your life so constantly that silence begins to feel unfamiliar. And yet, not everyone experiences inner speech the same way. Some people think mostly in words. Others think more in images, feelings, spatial patterns, music, or abstract understanding. Some have a constant narrator, while others have a quieter mental life. This means the voice you call normal may only be one style of consciousness among many. The self is not identical to inner speech. You are not only the sentence passing through your mind right now. You are also sensation, attention, memory, emotion, perception, and the quiet awareness that can notice the sentence. And perhaps that is the doorway to freedom. If the voice in your head was partly learned, it can also be examined. If it uses old tones, you can recognize them. If it repeats inherited fears, you can question them. If it speaks cruelly, you do not have to treat cruelty as truth just because it arrived in your own mental accent. The inner voice is powerful, but it is not always sovereign. It is a tool, a habit, a companion, a narrator, sometimes a protector, sometimes a frightened echo. So tonight, when a thought rises and speaks inside you, listen gently, but do not bow too quickly. Ask where it came from. Ask whether it helps. Ask whether it is truly yours, or only something the world once said so many times that your mind learned to whisper it back. And in that small pause, you may discover something quieter than the voice, the awareness that hears it and does not have to become it. Dreams can rewrite what you believe happened while awake. A dream can vanish by breakfast and still leave a fingerprint on what you believe happened in real life. You wake up and think the dream is gone, just a strange night scene dissolving in the first light of morning. But the brain does not always seal sleep and waking into separate rooms. During sleep, especially in dream-rich stages, the mind is not simply playing meaningless images. It is working with memory, emotion, threat, desire, unfinished thoughts, body signals, and fragments of recent experience. A face you saw for 1 second, a message you ignored, a fear you did not fully admit, a sound from the room, a conversation from yesterday. All of these can be pulled into the dream and rearranged into something that feels like a private movie. The danger is not that dreams are literal messages or secret prophecies. That would be too easy and often untrue. The real danger is subtler. Dreams can blur the source of a feeling. You may dream that a friend betrayed you, wake up knowing it was only a dream, and still feel a faint distance from them for the rest of the day. You may dream of failing, being chased, being loved, being abandoned, or finding something lost, and even after the story fades, the emotional residue can remain. The brain may remember the feeling more strongly than the fact that it was dreamed. This matters because memory is not only a record of events, it is also a record of emotional meaning. If a dream attaches fear, guilt, warmth, or suspicion to a person or situation, your waking mind may later treat that emotion as if it came from real evidence. Psychologists call this kind of confusion a problem of source monitoring. The brain sometimes keeps the content but loses track of where it came from. Did you actually hear that sentence, imagine it, read it, or dream it? Most of the time, you know the difference. But under stress, poor sleep, repetition, or emotional intensity, the boundary can soften. This is why a dream can feel like a memory while you are inside it. The sleeping brain can create places you have never visited, conversations that never happened, and versions of people that are built from fragments of truth and invention. Then waking consciousness returns and tries to sort the pieces. Usually it succeeds. Sometimes it leaves a trace behind. Sleep also plays a real role in memory consolidation, the process by which the brain strengthens, organizes, and integrates what you have learned or experienced. It does not simply replay the day like a recording. It extracts patterns, connects old and new information, and sometimes reshapes emotional weight. That can be helpful. A painful experience may feel less sharp after sleep. A problem may seem clearer in the morning. A skill may improve after rest, but the same creative system that helps you adapt can also mix imagination with memory. Dreams can rehearse threats that never occurred, resolve conflicts that never happened, or intensify worries that were only small while awake. And because the brain is designed to learn from emotionally charged simulations, a powerful dream may quietly teach your nervous system as if something important took place. This is why nightmares can leave the body tense long after the room is safe. The heart has slowed, the eyes are open, the bed is real, yet some part of you is still responding to a world that existed only in sleep. And perhaps the most unsettling part is that waking life is not fully protected from these night edits. You may not believe the dream literally, but you may carry its mood into your decisions, your interpretations, your sense of trust, even your self-image. A dream can make an old fear feel fresh. It can make a forgotten person feel present again. It can make a possibility feel strangely familiar, as if the mind has already lived it once in the dark. So when you wake from a dream that feels too real, do not rush to treat it as truth, and do not dismiss it as nothing. Hold it carefully. Ask what feeling it left, what memory it touched, what fear or hope it borrowed from your waking life. The dream may not tell you what happened, but it may reveal how your brain is organizing what happened, what it fears might happen, or what it has not finished feeling. And in that quiet space between sleep and morning, you may realize something strange. Your past is not only shaped by the day, it is also softened, colored, and sometimes rewritten by the night. Your sense of free will may be a story told after the fact. The feeling of free will may arrive like a king entering the room after the servants have already done most of the work. You experience choice as if a clear inner self stands at the center of the mind, looks over the options, gives an order, and then the body obeys. You say, "I chose this," and the sentence feels complete, honest, obvious. But the brain is not a simple throne room with consciousness sitting above everything else. It is a layered system where urges, memories, emotions, habits, bodily states, and hidden evaluations begin shaping action before the conscious narrator fully understands what is happening. In laboratory studies of simple voluntary movement, researchers have found that brain activity related to preparing an action can appear before a person reports the conscious feeling of deciding. Later, brain imaging studies suggested that, in some very simple button choice tasks, patterns in the brain can contain information about the upcoming choice several seconds before the person becomes aware of choosing. This does not prove that every serious decision in your life is an illusion. Choosing whether to leave a relationship, change your beliefs, forgive someone, tell the truth, or rebuild yourself after failure is far more complex than pressing a button in a scanner. But these experiments do reveal a crack in the ordinary story. Consciousness may not always be the first spark of action. Sometimes it may be the moment the brain turns hidden preparation into a feeling of authorship. The decision grows underground first, and only when it breaks the surface do you call it mine. Think about the ordinary choices you make without noticing their depth. You reach for one shirt instead of another, answer a message with warmth or coldness, avoid a difficult task, choose the familiar route, buy the snack you promised yourself you would not buy, and afterward your mind offers reasons. I liked the color. I was tired. It was not the right time. I deserved it. Some of these reasons may be true, but they may not be the whole truth. Beneath them may be a mood you did not name, a memory you did not recall, a fear you did not admit, a social cue you barely noticed, a body state shaping your judgment from below. The brain is constantly acting as a prediction and control system, preparing possibilities before conscious thought can inspect them. Then consciousness often builds a coherent story from the result. This storytelling is not useless. It helps you learn, explain yourself, maintain identity, and communicate with others. But it can also make you feel more in control than you actually were in the first moment. The sense of free will, then, may sometimes be retrospective. It may be the mind looking back at an action already forming and saying, "I caused that," because it needs life to feel unified. And yet, this does not make you powerless. A dangerous misunderstanding would be to hear this and think nothing matters. In truth, the deeper lesson may be that freedom is not only found at the instant of choice. It is built earlier in the conditions that shape what your brain is likely to prepare. Your habits matter because they train future impulses. Your environment matters because it places certain actions closer to you than others. Your sleep, stress, relationships, routines, and repeated thoughts matter because they change the hidden landscape from which choices arise. If you want to act differently, you may need to do more than command yourself in the final second. You may need to redesign the mind that reaches that second. This is why reflection, therapy, practice, education, and self-awareness can be powerful. They do not place a magical ruler above the brain. They slowly change the brain's probabilities, its pathways, its defaults, its emotional alarms, its sense of what is possible. Maybe free will is not a lightning bolt that appears out of nowhere. Maybe it is a long cultivation, a way of teaching your unconscious systems to serve the person you are trying to become. So when you feel a choice rise inside you, hold it with humility. It may be yours, but not yours in the simple way you imagined. It may have roots deeper than awareness, fed by yesterday's habits, old wounds, quiet desires, and the body's hidden weather. The story of choice may sometimes be told after the fact, but the storyteller can still learn. And perhaps that is where human freedom becomes more honest. Not in pretending you are separate from the machinery of your mind, but in patiently becoming the kind of mind whose hidden machinery begins to choose with wisdom. You may be blind to your own blind spots in thought. The most dangerous. Errors in your mind may not feel like errors at all. They may feel like clarity. You can doubt another person's judgment easily. Notice their contradictions. See when emotion bends their reasoning, or recognize when pride makes them defend a weak idea. But when the same thing happens inside you, it often arrives wearing the face of truth. This is the strange problem of mental blind spots. Your mind is not only capable of being wrong, it is capable of hiding its wrongness from itself. You do not experience most biases as biases. You experience them as just how things are. If you already believe something, your attention naturally drifts toward evidence that supports it and becomes less generous toward evidence that threatens it. This is often called confirmation bias, and it does not require stupidity or dishonesty. Intelligent people can fall into it even more skillfully because they may be better at building arguments for what they already want to believe. The mind is not a cold judge sitting above emotion. It is often a lawyer, quietly defending a position before you realize a trial has begun. This is why arguments rarely change people as quickly as facts should. A fact does not enter an empty room. It enters a room already filled with identity, loyalty, fear, memory, status, and the need to remain coherent. If a belief has become part of who you are, changing it can feel less like learning and more like losing a piece of yourself. So the brain protects the old structure. It questions the source. It attacks the tone. It finds one flaw and uses it to dismiss the whole message. It says, "I am being rational," while quietly guarding comfort. There is also something psychologists call the bias blind spot. The tendency to see bias in others more easily than in yourself. You may believe you are less influenced by emotion, advertising, social pressure, or group loyalty than the average person. But most people tend to think that way. The blind spot survives because you have access to your intentions, while you usually judge others by their behavior. When you make a harsh comment, you know the tiredness, stress, or hidden fear behind it. When someone else does the same, you may simply call them rude. Inside yourself, you see context. Outside yourself, you see character. This difference quietly distorts judgment every day. It shapes conflicts, politics, relationships, and even self-image. You may also mistake ease for truth. If an idea is familiar, repeated often, or expressed simply, it can feel more believable. The brain likes fluency. It trusts what moves smoothly. That is why slogans can feel stronger than careful explanations, and why a false idea repeated enough times can begin to feel strangely obvious. But obviousness is not the same as accuracy. Sometimes an idea feels true because your mind has walked that path many times before. And perhaps the deepest blind spot is the belief that introspection gives you full access to yourself. You can look inward and find reasons, feelings, and explanations, but you are not seeing the whole machine. Much of thought happens beneath awareness. Emotional tagging, threat detection, social comparison, memory selection, expectation, habit. Consciousness receives part of the result and then tells a story about why it happened. That story may be useful, but it may also be incomplete. This does not mean you can never trust your mind. It means trust should come with humility. A healthy mind is not one that never makes mistakes. It is one that can notice the possibility of mistake without collapsing. It can ask, "What am I not seeing?" It can pause before turning certainty into identity. It can listen to disagreement without instantly treating it as attack. It can separate the discomfort of being challenged from the danger of being harmed. This is difficult because the ego prefers clean innocence. It wants to be the clear observer, the fair judge, the reasonable one. But wisdom begins when you realize that your mind is not a window with perfect glass. It is a living instrument, shaped by needs, wounds, habits, and hopes. Some distortions protect you. Some limit you. Some once helped you survive, but now quietly narrow your world. So the next time you feel absolutely certain, do not immediately distrust yourself, but do not worship the feeling either. Certainty can be a light, but it can also be a shadow standing very close to your eyes. Ask what evidence would change your mind. Ask what you would think if someone you disliked made the same argument. Ask whether you are defending truth or defending the comfort of not having to change. Your blind spots do not disappear because you are intelligent, honest, or careful. They soften when you become willing to look where your mind least wants to look. And maybe that is one of the most difficult forms of awakening. Not seeing a new world outside you, but discovering the invisible corners inside your own thought. Your body map can be fooled into owning a fake limb. Your body may feel like the one thing you cannot be fooled about until a rubber hand on a table starts to feel like yours. This is not a magic trick, and it is not simply imagination. It is one of the most revealing experiments in neuroscience, known as the rubber hand illusion, and it shows how surprisingly flexible your sense of body ownership can be. The setup is simple. Your real hand is hidden from view. A fake rubber hand is placed in front of you where your hand could plausibly be, and both the hidden real hand and the visible fake hand are stroked at the same time with matching movements. After a while, many people begin to feel as if the rubber hand belongs to them. They know intellectually that it is fake. They can look at it and understand it is not flesh, not bone, not alive. But the deeper body system begins to accept it. If the fake hand is suddenly threatened with a hammer or knife, the person may flinch, feel alarm, or show stress responses as if something part of them is in danger. The reason is that your brain does not know your body only by looking inward. It builds a body map from several streams of information at once: vision, touch, muscle sense, joint position, balance, and the timing between what you see and what you feel. When these signals agree strongly enough, the brain can update the map. It asks, in its own silent way, "Where is my body and what belongs to me?" Most of the time, the answer is stable because your senses match. You see your hand move when you intend to move it. You feel touch where you see contact. Your muscles report the position of your limbs. But when vision and touch are carefully synchronized, the brain may choose the most coherent explanation, that the thing being touched in front of you is part of your body. This does not mean your real hand disappears from biology. It means body ownership is an active construction, not an unbreakable fact. Your nervous system is constantly maintaining the feeling of mine. And this idea reaches far beyond a fake hand on a table. People who lose a limb can sometimes feel a phantom limb, as if the missing arm or leg is still present, because the brain's body map does not instantly erase the lost part. In some therapies, mirrors or virtual reality can help reshape that map and reduce phantom pain for some patients by giving the brain new visual feedback. In virtual reality, people can begin to feel ownership over digital bodies if the movements and sensations line up convincingly enough. Even tools can become partly absorbed into body awareness. A blind person's cane, after enough practice, may feel less like an external object and more like an extension of touch reaching into space. A skilled musician, surgeon, or athlete can feel an instrument, tool, or racket almost as part of their action system. The boundary of the body is not as simple as the skin. It is negotiated by use, timing, attention, and sensory agreement. This is why the rubber hand illusion feels so unsettling. It reveals that the body you call me is not only a physical object. It is also a model the brain keeps updating so you can move safely through the world. That model is usually accurate enough to protect you, but it is not immune to persuasion. Your sense of self begins not in philosophy, but in the quiet certainty that this hand is mine, this pain belongs to me, this body is where I am. And if that certainty can bend under the right conditions, then the foundation of identity is more delicate than it appears. So when you look down at your hands, do not treat ownership as something simple. Your body is real, but the feeling of owning it is a living agreement between brain and sensation, renewed every moment. You are not just inside a body. Your brain is continually drawing the borders of that body. And sometimes, with the right illusion, those borders can move. The brain can invent explanations for choices it didn't make. Your brain can defend a decision with complete confidence, even when it was not the real source of that decision. This is one of the most uncomfortable findings in psychology, because it shows that the mind is not only a thinker, it is also an interpreter, a narrator, and sometimes a brilliant improviser. You like to believe that when you choose something, you know why. You picked this face because it felt kinder. You chose that shirt because the color suited you. You preferred one option because it was clearly better. But experiments on choice blindness reveal a stranger possibility. In some studies, people are asked to choose between two faces, two products, or two options, and then, without noticing, they are shown the option they did not choose. Astonishingly, many people still explain why they chose it. They describe preferences, details, and reasons with sincere confidence, even though the choice has been secretly switched. They are not trying to deceive the researcher. They are not pretending. Their brain receives the outcome in front of them and quickly builds a story that makes the outcome feel internally consistent. This means your explanations for your own behavior may sometimes be less like causes and more like after-the-fact repairs. The mind hates loose ends. It does not like the feeling of, I don't know why I did that. So when a gap appears between action and understanding, the brain often fills it with a reason that sounds plausible. This is called confabulation, and in dramatic cases it can be seen after certain brain injuries, where a person may invent explanations without realizing they are inventions. But milder forms happen in ordinary life too. You might buy something because of placement, mood, hunger, habit, or social pressure, then later say you made a careful, rational choice. You might dislike someone because their tone reminds you of an old experience. Then explain it as, I just don't trust them. You might follow the group because belonging feels safe, then call it independent judgment. The explanation may contain some truth, but it may not reveal the original machinery. The brain is constantly influenced by things outside awareness. Fatigue, lighting, order of presentation, emotional associations, body sensations, subtle rewards, fear of rejection, and the simple need to appear coherent to yourself and others. Afterward, consciousness steps in like a spokesperson at a press conference, giving a clean answer for a messy process. And this spokesperson can be very convincing because it speaks in your own voice. That is what makes the illusion so powerful. The explanation feels like direct access to the truth, when it may only be the best story your brain can assemble from limited evidence. This does not mean you never know your reasons, or that all self-reflection is fake. Humans can become more accurate through careful attention, feedback, therapy, journaling, science, and honest conversation. But it does mean that introspection is not a perfect window. Looking inward does not always show you the hidden causes of your behavior. Sometimes it shows you a narrative built to preserve continuity, and perhaps that narrative has a purpose. Without it, your life would feel fragmented. Actions here, emotions there, habits moving silently, impulses appearing from nowhere. The brain creates unity so you can function as a person. It turns scattered processes into a self you can understand. But wisdom begins when you stop mistaking every explanation for a confession of truth. So the next time you hear yourself saying, I know exactly why I did that, pause gently. Ask whether the reason came before the action or after it. Ask what else may have shaped the moment, the room, the mood, the people, the fear, the memory, the hunger, the need to belong. Your brain is not your enemy for inventing explanations. It is trying to make life feel whole. But wholeness is not the same as accuracy. And maybe the deepest lesson is this. To know yourself is not merely to listen to the story your mind tells. It is to notice the storyteller and to wonder what it had to hide in order to make the story feel complete. Attention can delete reality before it reaches consciousness. A sound can touch your ears. A shape can strike your eyes. A signal can enter your nervous system and still never become part of your conscious world. This is the quiet violence of attention. It does not merely highlight reality. It can erase parts of it before you ever know they were there. You usually imagine consciousness as the place where experience begins, but much of the brain's work happens before awareness opens its door. Sensory information arrives in enormous amounts every second, far more than the conscious mind can hold, compare, name, and respond to. So the brain does not let everything through equally. It filters early, sometimes brutally. It strengthens what seems relevant, weakens what seems useless, and blocks what would overload the system. This is why you can sit in a noisy cafe and follow one voice while dozens of other voices fade into a soft blur. The other sounds still reach your ears. The air still vibrates. The auditory system still receives patterns. But attention acts like a gate, allowing one stream to become meaningful while the rest becomes background. And then, suddenly, if someone across the room says your name, the hidden system may lift that sound out of the blur and push it into awareness. Your brain was not fully conscious of every word, but it was still monitoring enough to decide what deserved entry. Vision has similar gates. In rapid visual experiments, if two important images appear too close together in time, people may notice the first and completely miss the second, as if awareness blinked. This is called the attentional blink, and it shows that consciousness is not a perfect open field. It has a recovery time. It has limits. When the mind is busy processing one event, the next event can fall into a gap and vanish from experience. Visual masking reveals another strange layer. A stimulus can be shown very briefly, then followed by another image that prevents the first from reaching awareness, even though the brain registered something. The signal enters, but before it becomes a clear perception, another signal disrupts it. Reality does not simply appear because it touched your senses. It must survive competition. It must be selected, stabilized, and promoted into consciousness. Even pain, touch, and body signals can be shaped by attention. A small injury may go unnoticed during intense concentration, then suddenly ache when the danger or task is over. A repeated background sensation, the feeling of clothing on skin, the hum of a refrigerator, the pressure of a chair beneath you, fades because the brain decides it is not worth constant awareness. This is not laziness. It is efficiency. If every sensation stayed equally bright, you would drown inside your own body. The brain protects you by dimming the predictable, but the same protection can make reality incomplete. You do not experience the full world and then choose what to care about. In many cases, what you care about determines what world you experience at all. This is why attention is so powerful in fear, love, grief, and obsession. A fearful mind detects threat faster. A lonely mind notices rejection more easily. A hungry mind finds food cues everywhere. A grieving mind can see traces of the lost person in ordinary places. Attention changes the threshold for what becomes real to you. It does not change the outside world in a magical way, but it changes which parts of the outside world are allowed to enter the inner one. And perhaps this is why your life can shrink without the universe shrinking. Under stress, the world can become a tunnel. Under wonder, it can widen. Under habit, it can become invisible. Under curiosity, it can return in detail. The lesson is not that attention is bad. Without it, there would be no learning, no conversation, no art, no danger response, no deep thought. Attention is the blade that cuts a usable path through chaos. But every blade has an edge, and whatever it cuts away may disappear so completely that you never mourn its loss. So tonight, as you listen, imagine consciousness not as a window thrown open to everything, but as a small stage with limited light. Many signals wait in the dark around it. Some are invited forward, some are rejected, Some touch the curtains and vanish. Your reality is not only made of what exists, it is made of what attention allows to arrive. And maybe the most haunting question is not, what am I looking at? But what did my mind delete before I knew it was there? Your identity may change, while your mind pretends it stayed the same. One of the quietest tricks your mind performs is making a changing person feel like the same person all the way through. You look back at old photos, old messages, old fears, old dreams, and you say, that was me, as if identity were a single thread pulled cleanly through time. But if you look more carefully, the thread is full of knots, replacements, edits, and silent departures. The person who once wanted one life may now want another. The person who once feared being judged may now fear wasting time. The person who once needed approval may now need peace. Your values shift. Your emotional reactions change. Your habits reshape your days. Your relationships teach you new versions of yourself, and your brain updates its wiring through experience. Yet through all of this, the mind keeps producing a feeling of continuity. Because without that feeling, life would become psychologically difficult to hold. You need to believe there is a stable you who made promises yesterday and will wake up tomorrow. You need continuity to love, to plan, to apologize, to learn, to recognize your own reflection. But continuity is not the same as sameness. A river can keep its name while its water is constantly replaced. A city can keep its skyline while people move. Buildings change, streets are repaired, and whole neighborhoods transform. In the same way, your identity can keep a familiar shape while its inner material slowly changes. Psychologists have found that people often underestimate how much they will change in the future. You may look at your past self and clearly see transformation, yet still imagine your present self as the final version, the one who has finally arrived. This is sometimes called the end of history illusion. The tendency to recognize past change but underestimate future change. It reveals how strongly the mind wants the current self to feel complete. But you are not complete in that frozen sense. You are still being shaped by repetition, stress, sleep, love, grief, work, culture, failure, attention, and the environments you return to every day. Even the roles you play can quietly become part of you. Act confident long enough in a demanding role, and confidence may begin to feel natural. Live for years under criticism, and caution may become part of your personality. Care for someone deeply, and your priorities may rearrange around responsibility. Move to a new country, learn a new language, lose a friend, recover from illness, become a parent, begin a craft, survive disappointment. Each experience can change what feels important, what feels possible, and what kind of person you believe you are. The mind does not mark every shift with a ceremony. It simply absorbs them, smooths them into the story, and whispers, I have always been this way. But often, you have not. You have become this way. That difference matters. If you mistake your current identity for a permanent truth, you may trap yourself inside old labels. Shy, broken, angry, unlucky, weak, unlovable, not creative, not disciplined, not the kind of person who changes. But many labels are only snapshots of a process. They describe a pattern that has existed, not a law that must continue. This does not mean change is easy, or that anyone can become anything by simply wishing it. Biology, history, trauma, opportunity, and environment all matter. But the brain remains adaptable across life. It can strengthen certain pathways and weaken others. It can learn new emotional responses. It can become more skilled at attention, patience, language, movement, compassion, or self-control through repeated practice and support. Identity is not clay you can reshape instantly with a slogan, but it is not stone either. It is more like a garden that remembers every season while still growing into the next. And perhaps the strangest part is that you may only notice change after it has already happened. One day, something that used to hurt no longer reaches as deeply. A place that once felt like home feels distant. A dream that once pulled you forward has gone quiet. A boundary you could never set now leaves your mouth calmly. You did not become someone else overnight. You changed by small degrees, while the mind protected the illusion of one continuous self. So when you ask who you are, be careful not to answer too quickly. The answer may be true only for this chapter. You are not a fixed object being carried through time unchanged. You are a living pattern, preserving enough continuity to remain recognizable, changing enough to survive. And maybe that is the soft mercy hidden inside identity. The mind pretends you stayed the same so you can feel whole. But life keeps changing you so you can become more than what you were. The universe may be larger than anything that can ever be known. The most terrifying thing about the universe may not be how much we know, but how much may remain unknowable forever. You can imagine science as a lantern moving through darkness, slowly making the unknown visible. And in many ways, that image is true. Human beings have measured the age of the universe, mapped galaxies across enormous distances, detected ancient radiation from the early cosmos, discovered planets around other stars, and learned that the atoms in your body were shaped by stellar history. But the lantern has limits. It does not expand infinitely just because curiosity does. The universe may contain regions, events, and structures that can never send information to us. Not because our telescopes are too weak today, but because the laws of light, time, and cosmic expansion place hard boundaries around what can ever be observed. The observable universe is not the whole universe. It is the part from which light has had time to reach us since the hot early stages of cosmic history. Beyond that horizon, there may be more space, more galaxies, more matter, perhaps even regions so distant that their light will never arrive no matter how long intelligence waits. And if cosmic inflation happened as many models suggest, the entire universe could be vastly larger than the portion we can see, possibly so large that our observable region is only a tiny patch inside a much greater whole. We do not know whether the total universe is finite or infinite. We do not know whether it repeats, curves back on itself, stretches without end, or contains structures forever outside measurement. This is not a failure of imagination. It is a boundary of evidence. Science is powerful because it does not claim what it cannot test. It builds knowledge from signals that can reach us, patterns that can be measured, predictions that can be checked. But if something lies permanently beyond every possible signal, it becomes different from an ordinary mystery. An ordinary mystery says, "You do not know yet." A cosmic limit may say, "No observer from your region can ever know directly." Even the cosmic microwave background, the oldest light we can see, is not the beginning itself. It is a glowing surface from a time when the universe became transparent enough for light to travel freely. Before that, the early cosmos was opaque to light, so we cannot simply look farther back with a better telescope and watch the first instant unfold. We infer earlier stages through physics, traces, particles, and patterns. But there may always be a veil between observation and origin. This means the universe is not merely large in distance. It is large in what it withholds. It contains horizons of space, horizons of time, horizons of energy, and horizons of theory. There may be truths that are real but unreachable, like pages of a book sealed beyond a glass wall. You can see that the book continues. You can infer some of its language, but you may never read every page. And yet, there is something strangely beautiful in this limitation. Knowledge becomes more precious when it is not guaranteed. The fact that the universe is partly knowable at all is astonishing. A small species on one planet can look at faint light, measure subtle patterns, and reconstruct billions of years of cosmic history. From inside the darkness, the mind can still form a map. But wisdom begins when the map does not pretend to be the territory. The known universe may be a shoreline, not the ocean. The equations may be windows, not the sky itself. The deepest reality may be larger than every instrument, every theory, every future archive, every possible civilization's memory. So when you look upward and feel the vastness pressing silently above you, remember that the stars are not the full confession of existence. They are the part of the story close enough, old enough, and bright enough to reach us. Beyond them may be more than we can ever prove, more than we can ever visit, more than any mind can gather into one final picture. And perhaps that is not a reason to despair. Perhaps it is the final form of wonder, to learn honestly, to question deeply, and still accept that reality may always be larger than the circle of light we call knowledge. The observable universe may be only a tiny bubble of reality. Imagine discovering that the universe you call everything may only be the inside of a bubble drawn by light, not a physical glass bubble, not a wall you could crash into with a spaceship, but a boundary created by time itself, the distance from which light has had enough time to reach us since the universe became transparent and visible. This is what scientists mean by the observable universe. It is not the whole of reality. It is the region of reality that has been able to speak to us through light, radiation, gravity, and cosmic signals. The universe is about 13.8 billion years old. Yet the observable universe reaches much farther than 13.8 billion light years in every direction, because space itself has expanded while the light was traveling. The galaxies whose ancient light reaches us today are now far more distant than they were when that light began its journey. So when you picture the observable universe, do not imagine a simple sphere of stars sitting still around Earth. Imagine a growing cosmic bubble of information, a sphere of reachable evidence, with us at the center only because every observer is at the center of their own visible horizon. A civilization in a galaxy far away would have its own observable bubble, overlapping with ours in some regions and reaching into regions we can never see. This means the universe and the universe we can observe are not the same thing. The first may be the full ocean. The second is only the water close enough for its waves to touch our shore. And inside our bubble, there is already almost too much to understand. Hundreds of billions of galaxies, vast filaments of cosmic structure, dark regions between clusters, ancient light stretched by expansion, and the faint afterglow of the early universe spread across the sky. Yet all of this might be only a tiny sample. If the larger universe continues beyond our horizon, then the most distant galaxies we can detect are not sitting near the edge of existence. They are only near the edge of our evidence. Beyond them may be more galaxies, more empty space, more structure, perhaps a continuation so enormous that our visible cosmos becomes like one glowing room inside a building with no known end. The unsettling part is that the boundary is not caused by poor technology. Better telescopes can reveal fainter objects, sharper details, older light, and hidden patterns, but they cannot make light arrive before it has had time to travel. A telescope is powerful, but it cannot defeat the history of the universe. It can only collect messages that have actually reached us. The edge of the observable universe is therefore not an edge where reality stops. It is an edge where information stops, at least for us. This changes the emotional meaning of the night sky. The darkness above you is not empty simply because there is nothing there. Some of it is dark because the messages from beyond have not arrived, and some may never arrive in a useful way because expansion keeps stretching the distance between regions of space. The visible universe becomes a kind of cosmic biography, written from the signals that manage to cross the distance. It tells us an astonishing amount, but it may not tell us the whole story. And this is where humility enters. Human beings often mistake the limits of perception for the limits of reality. Once, the visible horizon on Earth felt like the edge of the world. Now the cosmic horizon can tempt the mind in the same way. But the edge of what can be seen is not necessarily the edge of what exists. The observable universe may be magnificent, ancient, and almost impossible to imagine, yet still only a small bubble inside something larger. So when you hear the word universe, let it become less certain and more mysterious. There is the universe we map, the universe we infer, and perhaps the universe forever outside the reach of our signals. We live inside a bubble of light, reading the messages that made it across time. And the deepest wonder is not only that the bubble may be small, but that from within it, a fragile mind can look outward and realize there may be more reality than reality will ever show. Cosmic expansion is slowly erasing the evidence of other galaxies. The future sky may become so empty that intelligent beings could look upward and never discover the universe we know today. This is one of the loneliest consequences of cosmic expansion. It does not only move distant galaxies away from us, it slowly takes away the evidence that those galaxies were ever part of our reachable cosmic story. Right now, the universe still gives us clues. We can see galaxies beyond the Milky Way. We can measure their light stretched toward redder colors as space expands. We can detect the faint afterglow of the early universe, the ancient background radiation that tells us the cosmos was once hotter, denser, and more uniform. We can map great webs of galaxies and infer that the universe has a history larger than our own galaxy. But this evidence is not guaranteed forever. Because expansion is accelerating, galaxies that are not gravitationally bound to our local region will drift farther away in a deeper sense. Their light will become stretched, dimmed, and eventually so difficult to receive that they will fade beyond practical observation. They will not vanish because they are destroyed. They will vanish because the space between here and there keeps growing, pulling their signals into silence. The process is slow beyond ordinary human imagination, measured over immense cosmic times, but the direction is clear. The far future will not see the same universe we see. Our own local group of galaxies, including the Milky Way and Andromeda, is bound strongly enough by gravity to remain together and eventually merge into a larger galaxy-like system. But beyond that local island, more and more of the cosmic ocean will slip out of view. To future astronomers living in that distant era, the night sky may suggest a much smaller reality. They may see a great galaxy surrounded by darkness and mistake their local island for almost everything that exists. The evidence of expansion could become faint. The ancient background radiation will keep stretching to longer and longer wavelengths, cooling and weakening until it may be nearly impossible to detect. The distant galaxies that once revealed the expanding universe will be gone from view, their light diluted into the darkness. In that future, the most important clues about cosmic history may no longer be available. The universe will not have changed its past, but it will have hidden the records. This is a strange thought. Truth can depend on when you exist. The same laws may operate, the same history may have happened, but observers in one era may have access to evidence that observers in another era can never gather. We are living in a time when the universe is still readable. Not fully readable, not completely open, but generous enough to leave fingerprints across the sky. We can see ancient light, distant galaxies, expanding structure, and the large-scale pattern of matter. Future minds may not be so lucky. They may be brilliant, careful, and curious, yet trapped inside a darker archive. Their instruments may be far more advanced than ours, but if the signals are no longer arriving, intelligence cannot simply invent the missing evidence. Science needs messages from reality, and cosmic expansion is slowly carrying some of those messages away. This does not mean knowledge is hopeless. It means knowledge has seasons. There are windows in cosmic history when certain truths can be discovered, and windows when they may close. We often think of the universe as something passive, waiting eternally to be understood. But perhaps it is more like a fading manuscript. Some pages are already hard to read. Some pages are being stretched thinner by time. Some pages may one day be lost beyond the horizon of any observer, and that makes our moment feel strangely precious. When we look at deep space images, when we measure old radiation, when we study galaxies whose light began traveling before Earth had complex life, we are not just satisfying curiosity. We are collecting evidence before the universe hides more of itself. The sky above us is not only beautiful, it is historically fragile. Its distant lights are records, and records can fade. So when you hear that expansion is carrying galaxies away, do not picture simple motion through empty space. Picture a cosmic library whose farthest shelves are slowly receding into darkness, while we stand inside one illuminated room, reading what we can before the silence grows. The universe is not erasing reality itself, it is erasing access. And sometimes, losing access to the truth can look almost the same as losing the truth. The universe might be flat without having an edge. The universe could be flat in the deepest geometric sense and still have no wall, no rim, no final cliff where existence drops into nothing. This sounds impossible at first because the word flat makes the mind picture a sheet of paper, a table, a disk, something with edges you could eventually reach. But in cosmology, flatness does not mean the universe is shaped like a pancake floating in darkness. It means that, on the largest scales we can measure, space appears to follow a geometry where light travels in the straightest possible paths. Parallel lines do not naturally converge or spread apart because of cosmic curvature, and enormous triangles behave almost the way they would on a flat surface. The question is not whether planets, stars, and galaxies sit on a flat plane. They do not. Space has 3 dimensions around us, and gravity can curve it locally near massive objects. The larger question is about the overall geometry of the universe itself. Imagine 2 travelers setting off in perfectly straight lines across a sphere like Earth. Even if they begin parallel near the equator, their paths can eventually meet because the surface is curved. Now imagine a saddle-like surface where paths can spread apart in a different way. Cosmologists ask a similar question about the whole cosmos. If beams of light travel across billions of light years, does the geometry of space make them converge, diverge, or remain almost perfectly balanced? One of the most important clues comes from the ancient afterglow of the early universe, the cosmic microwave background. Tiny patterns in that radiation act like marks on a very distant surface, and by studying their apparent size, scientists can test the curvature of space. So far, the best measurements suggest that the universe is extremely close to flat, at least within the limits of what we can observe. But flatness does not answer every question. A flat universe could be infinite, stretching endlessly without a boundary. It could also, in some more exotic possibilities, be finite but connected in a way that has no edge. A little like how certain video game worlds let you leave one side of the map and re-enter from the other, though the real universe would be far more subtle than that analogy. The key idea is this: an edge is not required for finiteness, and flatness is not the same as having a border. Human intuition struggles here because we evolved inside rooms, fields, roads, and horizons. Everything around us seems to have a surface, a limit, a container. A cup has an inside and outside. A house has walls. A country has borders. Even Earth, though it has no edge you can fall from, still has a surface embedded in surrounding space. But the universe is not necessarily an object sitting inside a larger room. It may not need an outside. Asking where the edge of the universe is may be like asking where the edge of Earth's surface is while walking around the globe. You can travel and travel, but the question itself may be built from the wrong picture. If space is flat and infinite, there is no final boundary because there is always more space ahead. If space is finite but unbounded in some deeper topology, there may still be no edge because the geometry connects back or closes in a way that does not require a wall. Either way, the mind is forced to release one of its oldest habits, the belief that everything must end the way ordinary objects end. And this makes cosmic flatness strangely haunting. It is not the flatness of simplicity, it is the flatness of a reality too large and too fundamental to be imagined as a shape you could hold in your hands. There may be no cosmic fence, no final signpost, no place where a traveler reaches the end and sees what lies beyond. The universe may be open not because it is easy to cross, but because its structure does not offer the kind of boundary our instincts expect. So when you hear that the universe might be flat, do not picture a thin sheet in empty darkness. Picture a vast 3-dimensional reality whose geometry may be balanced so precisely that across unimaginable distances, space does not curve overall in a way we can detect. Picture a cosmos where flat means not small, not simple, not edged, but mysteriously even. A place where the deepest shape may hide behind the fact that there may be no final shape to look at from the outside. And perhaps that is the quiet lesson. The universe does not have to match the shapes our minds learned from tables, rooms, and maps. It can be flat without being a floor, finite without having a wall, endless, without needing to explain what it is expanding into. Reality is not obligated to end in a way the human imagination can stand beside. Gravity is not pulling you the way your intuition says. The ground beneath your feet may be doing more to create the feeling of gravity than the Earth's pull itself. That sounds backward, because every instinct tells you gravity is a downward force grabbing your body and dragging it toward the planet. In everyday life, that picture works well enough. Newton's idea of gravity as an attractive force is still extremely useful for calculating falling objects, orbits, tides, and spacecraft paths. But Einstein's deeper view changes the meaning of what is happening. In general relativity, gravity is not best understood as an invisible hand yanking you downward through space. It is the effect of mass and energy shaping spacetime, and objects moving through that shaped spacetime follow the straightest possible paths available to them. A falling object is not fighting against anything. In a strange sense, it is moving naturally. If you dropped a ball from a tower, the ball is not trying to fall in the way your intuition imagines. It is following a path through curved space-time around Earth. The more surprising part is what happens to you when you stand still. You feel weight because the ground stops you from following that same natural falling path. Your body wants to move along the curved path toward Earth's center, but the floor, chair, or ground pushes upward on your feet and prevents it. That upward support force travels through your bones, muscles, and skin, and your nervous system interprets it as weight. This is why astronauts orbiting Earth feel weightless, even though Earth's gravity is still acting strongly on them. They are not beyond gravity. They are continuously falling around Earth, moving forward fast enough that the planet curves away beneath them as they fall. Their spacecraft, their bodies, their tools, and the air inside all share the same falling motion, so there is no floor pressing upward in the familiar way. Without that pressure, the body does not feel weight. The same idea appears in a falling elevator thought experiment. If the cables somehow broke and the elevator fell freely, everything inside would float relative to the elevator for a short time. The people inside would not feel the usual pull, because they and the elevator would be following the same falling path together. This reveals something deeply counterintuitive. Gravity itself does not always feel like gravity. What you feel as heaviness is often resistance to free fall. The sensation of standing on Earth is not simply the Earth pulling you down. It is also the Earth refusing to let you fall freely through it. And yet gravity is not an illusion. It bends the paths of planets, shapes galaxies, guides light around massive objects, creates tides, collapses stars, and gives the universe much of its structure. But its deepest behavior is not like a rope stretched between things. It is more like the geometry of reality telling motion how to unfold. A planet does not need to be physically pulled by a visible cord to orbit the sun. It moves through curved space-time in a way that looks to us like a continuous fall around the sun. Light itself, which has no ordinary mass, can bend near a star or galaxy because the path of space and time around that object has changed. This is why gravitational lensing can make distant galaxies appear distorted, duplicated, or magnified, as if the universe has placed a cosmic glass between us and the source. Your intuition evolved for small speeds, solid ground, thrown stones, and falling fruit, not for curved space-time. So it gives you a useful story. Things fall because gravity pulls. Science does not completely throw that story away. It places it inside a deeper one. At the human scale, the simple picture works. At the cosmic scale, it becomes too small. The truth is stranger. Standing still on Earth is not as passive as it feels. You are being held away from your natural path by the surface of the planet. The pressure under your feet is the planet saying in physical language, "You cannot fall through me." So the next time you feel your own weight, do not imagine only a mysterious force dragging you downward. Imagine space-time curved around a massive world, your body trying to follow the path carved by that curvature, and the ground pressing upward to keep you in place. What you call gravity is not just a pull. It is a relationship between motion, geometry, mass, and resistance. And the ordinary feeling of standing still is, in a deeper sense, the feeling of being prevented from falling through the shape of reality. Information may be more fundamental than matter. A universe made only of stuff would be strangely silent, because what gives stuff meaning is the pattern it carries. Take a book, for example. Its pages are made of ordinary material, paper, ink, glue, fibers, molecules. But the book is not valuable because of the weight of its ink. It matters because the ink is arranged into letters, the letters into words, the words into ideas, and the ideas into something that can change a mind. The same physical substance can be a blank page, a love letter, a scientific equation, a confession, or a warning, depending on how it is organized. This is why some scientists and philosophers have wondered whether information may be more fundamental than matter itself, not in a magical sense, and not as a proven final answer, but as a serious way of looking at reality. Matter tells you what something is made of. Information tells you how it is arranged, what state it is in, what differences exist, what can be known, what can happen next. A living cell is not alive merely because it contains carbon, oxygen, hydrogen, and nitrogen. Those atoms exist in rocks, air, and oceans too. What makes the cell astonishing is the organization. Membranes separating inside from outside, molecules sending signals, proteins folding into useful shapes, DNA storing instructions in the chemical code, repair systems correcting mistakes, energy flowing through controlled pathways. Life is matter arranged so precisely that it can preserve and copy information about itself. Your brain is similar in a deeper way. It is made of cells, chemistry, and electrical activity. But your memories, habits, fears, language, and sense of meaning are not stored as tiny objects sitting in a drawer. They exist as patterns of connection and activity. Change the pattern and the experience changes, even if much of the material remains. This is where information begins to look less like an extra feature and more like a hidden skeleton of reality. In physics, to describe a system, you do not only list the particles inside it, you describe their state, where they are, how they move, how they relate, what energy they carry, what possibilities are open or closed. Two systems can contain the same kinds of particles and still be completely different, because their information is different. A diamond and graphite are both made of carbon, yet their atoms are arranged differently, giving one hardness and brilliance, the other softness and darkness. The difference is not the ingredient, it is the structure. Even at the quantum level, what matters is not simply that a particle exists, but the information contained in its state, its relationships, its possible outcomes, and how it changes when it interacts. This does not mean the universe is literally a computer screen, or that matter is fake. Matter is real, energy is real, forces are real, but perhaps what we call things are inseparable from the information that defines them. A thing without structure, relation, or state would be almost impossible to describe. It would be like a word with no letters, a melody with no order, a face with no pattern. The deeper you look, the more reality seems to depend on differences. This rather than that, here rather than there, connected rather than separate, ordered rather than random, possible rather than impossible. Information is the language of those differences. It is what lets the universe have memory in fossils, genes, scars, photons, brain circuits, and cosmic traces. Every footprint in mud is matter carrying information about a step. Every ring inside a tree records a season. Every spectrum of starlight carries clues about temperature, motion, and chemical elements. The world is not only filled with objects, it is filled with records. And maybe that is why information feels so fundamental. Without it, reality would still exist in some raw sense, but it would not tell a story, preserve a past, build a body, form a mind, or allow knowledge to arise. So when you look at your hand, a stone, a cloud, or a star, do not see only material. See arrangement, see relation, see a pattern temporarily holding itself together against change. The matter is the ink, but the information is the sentence. And perhaps the universe is not merely a warehouse of things, but a vast unfolding message, written not in words, but in structure, difference, memory, and transformation. Black holes may store reality on their boundaries. A black hole may hide its deepest secrets not in its darkness, but on the invisible skin around it. That sounds almost impossible, because intuition says that if something falls into a black hole, a star, a planet, a book, a person, a beam of light, its information should belong to the inside. The center feels like the vault. The boundary feels like the doorway. But modern physics has spent decades being disturbed by a stranger possibility. The edge of a black hole may somehow encode what the black hole contains. This edge is called the event horizon, the point beyond which escape is no longer possible for light or anything else. It is not a solid surface you could stand on, and it is not a glowing shell in ordinary space. It is a boundary in fate. Outside it, paths can still lead back out. Inside it, all paths lead deeper in. For a long time, black holes seemed like perfect destroyers of information. Drop something in, and from the outside, it appears gone forever. But quantum physics carries a powerful rule. Information about physical states should not simply vanish from the universe. This tension became known as the black hole information paradox, and it forced physicists to ask a haunting question. If a black hole eventually gives off Hawking radiation and slowly shrinks over immense time, what happens to the information about everything that fell in? Is it destroyed, hidden, scrambled, or somehow released? The clue that changed everything came from the work of Jacob Bekenstein and Stephen Hawking, who showed that black holes have entropy, a measure related to hidden information, and that this entropy depends not on the volume inside the black hole, but on the area of the event horizon. That detail is astonishing. In ordinary life, if you want to store more stuff, you think about volume, a bigger box, a bigger room, a bigger warehouse. But black holes suggest that the maximum information a region can hold may be tied to its boundary area, not the space inside it. This led to the holographic principle, the idea that the information describing a volume of space might, in some deep way, be represented on a lower dimensional boundary, almost like a hologram where a flat surface can contain the data needed to create the appearance of depth. This does not mean the universe is literally a cheap projection, or that your life is fake. The word holographic is an analogy for a serious mathematical idea, not a claim that reality is an illusion on a cinema screen. But it does suggest that our normal picture of inside and outside may be too simple. A black hole may scramble information across its horizon in an unimaginably complex way, like a message shredded so thoroughly that it looks meaningless, yet is not truly erased. From the outside, the horizon becomes less like a mouth that swallows reality and more like a cosmic ledger, a place where the universe keeps account of what has crossed the line. The information may not be readable in any practical way. It may be mixed beyond recognition, hidden in subtle correlations, or preserved in a form no ordinary observer could decode. But the possibility matters because it changes the emotional meaning of black holes. They are not merely holes in space. They are testing grounds where the deepest rules of gravity, quantum physics, thermodynamics, and information collide. They ask whether reality allows perfect forgetting. They ask whether destruction is ever total. They ask whether the surface of something can know more than its depth seems to reveal. And if the holographic idea reaches beyond black holes, then boundaries may be far more important than we ever imagined. The edge of a region may not be just where that region ends. It may be where its information is counted. So when you picture a black hole, do not see only a dark sphere swallowing stars in silence. Picture a boundary so extreme that it forces physics to confess its hidden structure. Picture information stretched, scrambled, and preserved on a horizon no hand can touch. Picture a place where the universe appears to erase, yet may be secretly refusing to forget. And perhaps that is the most unsettling thought of all. Reality may not store its deepest truths where our intuition looks for them. The center may be silent, while the boundary remembers everything. The beginning of the universe may not have been a beginning at all. The first page of the universe may not be a first page at all, but the place where our current story stops being able to read. When people hear the Big Bang, they often imagine a tiny point exploding into empty darkness, as if the universe began like a firework in a pre-existing space. But modern cosmology is more careful than that. The Big Bang theory does not simply claim to know the absolute first moment of everything. What it describes extremely well is that the universe was once much hotter, denser, smoother, and more compressed than it is today. And that space itself has been expanding and cooling ever since. The evidence for this is powerful. Galaxies are moving away from one another on large scales. The early universe left behind a faint afterglow, and the amounts of light elements like hydrogen and helium match what we expect from a hot early phase. But when scientists try to push the story all the way back to the very beginning, the rules become uncertain. The deeper we go, the more gravity, quantum physics, energy, and space-time itself enter a realm where our best theories do not yet fully fit together. At some point, the phrase "before the Big Bang" may become difficult, not because curiosity is wrong, but because time itself may not work there in the ordinary way. If time emerged with the universe as we know it, then asking what happened before time could be like asking what is north of the North Pole. The question feels natural, but the map may no longer support it. And yet, that is not the only possibility. Some serious scientific ideas suggest that the hot Big Bang may have been a transition rather than an absolute creation. Perhaps the universe passed through an earlier phase before expanding. Perhaps there was a cosmic bounce where a previous contracting universe reached an extreme state and then expanded again. Perhaps inflation, a very rapid early expansion, came from a deeper physical condition we still do not fully understand. Perhaps what we call the beginning is only the edge of a region our equations can describe, while a more complete theory would reveal a longer, stranger history. None of these ideas should be treated as proven facts. They are attempts to explore what might lie behind the earliest visible chapter. The honest truth is more mysterious. We know a great deal about the universe after its earliest moments, but we do not yet know whether the universe began from absolute nothing, from a prior state, from a quantum event, from a bounce, from a deeper timeless structure, or from something our current language cannot properly picture. This is why the beginning of the universe is not just a scientific problem. It is a problem of imagination. Human minds are trained by ordinary events. A match is struck, a song begins, a child is born, a door opens. Everything seems to have a before and an after. So we carry that instinct into the cosmos and search for the first tick of the clock. But the universe may not be an object inside time. Time may be one of the things the universe produces. The clock may not have been waiting in the dark before reality arrived. The clock may be part of reality's unfolding. That possibility changes the emotional weight of the question. The beginning may not be a sharp wall where existence suddenly appears from nowhere. It may be a horizon of understanding, a boundary where familiar ideas like cause, before, after, and place begin to lose their ordinary meaning. And perhaps that is why the question remains so haunting. We are not only asking how the universe started, we are asking whether starting is even the right word for something as deep as space-time itself. So when you imagine the origin of everything, do not picture a simple explosion in darkness. Picture a veil at the edge of knowledge, behind which our concepts begin to bend. Picture a hot early universe whose traces still surround us, but whose deepest source remains hidden behind unfinished physics. The beginning may have been a beginning, or it may have been a transformation, a boundary, a bounce, an emergence, or something no human metaphor can hold. And maybe the most honest wonder is this: the universe may not have started the way things start inside the universe. Reality may have opened not with a first moment we can easily understand, but with the birth of the very rules that make moments possible. Nothingness may be physically impossible. Nothing may be the one thing the universe refuses to give us. You can empty a room, remove the furniture, silence the machines, turn off the lights, and say there is nothing there. But there is still space, still time, still air unless you remove it. Still temperature, still gravity, still the possibility that something could enter. Even if you imagine a perfect laboratory vacuum, with every atom removed, physics would still not call it absolute nothing. There would still be a place where the vacuum exists, a measurable state, a background structure, fields with their lowest possible energy, and laws describing what can and cannot happen. This is the first strange lesson. Physical nothingness is usually not true nothingness. It is a kind of emptiness inside a framework. Absolute nothing would be far more radical. It would mean no space, no time, no matter, no energy, no fields, no laws, no mathematics acting in the background, no potential, no before, no after, no stage on which absence could sit. But the moment you try to describe it, you almost smuggle something back in. You imagine darkness, but darkness is still a visual idea. You imagine empty space, but space is already something. You imagine silence, but silence requires time in which sound could have occurred. You imagine a blank void, but a void has extension, boundary, or at least possibility. True, nothing is not a black room. It is not an empty container. It is not a silent universe waiting to be filled. It is the absence of the container itself. And that may be why physics struggles with it so deeply. Physics studies states, changes, relations, measurements, and rules. But absolute nothing has no state, no change, no relation, no clock, no distance, and no observer. It is not a thing among things. It may not even be a possible condition that can be meaningfully placed inside a scientific explanation. Some ideas in cosmology suggest that universes might arise from quantum states that are sometimes casually called nothing. But those proposals do not usually mean absolute philosophical nothingness. They often involve a quantum framework, laws, possibilities, or a kind of pre-geometric condition. That is not nothing in the pure sense. It is something very strange, something far emptier than ordinary reality, but not a total absence of all being. This distinction matters because the word nothing can mislead the imagination. When people ask why there is something rather than nothing, they are not just asking why space is empty or full. They are asking why there is any reality at all, why there are laws instead of no laws, why existence is possible instead of impossible. And here, science becomes humble. It can trace the universe back to hotter, denser, earlier conditions. It can describe how structure formed, how atoms emerged, how stars made heavier elements, how planets gathered, how life became possible. But the question of absolute nothing may sit at the edge of what explanation can grasp, because explanation itself needs something to work with. A cause needs a context, a law needs a domain, a transition needs time or something like time. If there is truly nothing, then there may be no mechanism by which nothing could become something, because a mechanism would already be something. This does not prove that nothingness is impossible, but it shows why it may be physically impossible to define, produce, or observe. The universe may not offer absolute absence as an option. It may only offer different forms of presence, matter, radiation, fields, geometry, information, possibility, laws, or deeper structures we do not yet understand. Even emptiness, when examined closely, becomes a kind of reality with rules. And perhaps that is the haunting reversal. Nothingness feels simple because it contains no objects, but it may be the hardest idea the human mind can form. Something is familiar, nothing is almost unthinkable. So when you stare into darkness and imagine the universe disappearing, remember that you may still be imagining too much. You may be leaving behind space, time, silence, distance, and the idea of an empty stage. True nothing would remove even the stage. And maybe existence is not a rare interruption of nothingness, but the only kind of condition reality can have. Perhaps the deepest mystery is not why nothing turned into something, but whether nothing was ever a possible alternative at all. The ordinary world may say, be the simplified version of something deeper. The world may look ordinary only because your mind is seeing the low-resolution version that lets you survive. A table seems solid, a flame seems simple, A voice seems like one smooth sound. A living body seems like one object. And a human personality seems like a single stable thing moving through time. But underneath each familiar surface is a deeper level where the simplicity breaks apart. The table is not table-like at the scale of atoms. It is a vast organized structure of particles, bonds, empty gaps, electrical forces, and constant motion. A flame is not a glowing object sitting in one place. It is an ongoing chemical process, a pattern of fuel, oxygen, heat, light, and rapid transformation. A voice is not one thing either. It is air pressure changing in waves, shaped by lungs, throat, tongue, mouth, and then rebuilt by a listener's nervous system into meaning. The ordinary world is not fake, but it is compressed. It is reality simplified into forms a human brain and body can use. This is one of the most powerful ideas in science. Different levels of reality have different languages. At one level, water is something you drink. At a deeper level, it is molecules moving, attracting, colliding, freezing, boiling, forming droplets, carrying heat. At one level, temperature feels like warmth or coldness on your skin. At a deeper level, it reflects the motion and energy spread through enormous numbers of tiny particles. At one level, life looks like animals, plants, hunger, sleep, growth, aging. At a deeper level, it is chemistry organized into self-maintaining systems, with cells reading instructions, repairing damage, managing energy, and communicating across microscopic boundaries. No single level tells the whole truth by itself. If you describe a bird only as atoms, you lose flight, song, instinct, nest building, and migration. If you describe a city only as buildings, you lose traffic, memory, economy, fear, celebration, loneliness, and culture. Higher levels are not illusions just because they are built from lower levels. They are patterns that become real when many smaller parts interact in stable ways. This is called emergence, the appearance of new properties when simple components organize together. Wetness is not found inside one isolated water molecule. It appears when countless molecules interact as a liquid. A single neuron does not contain a thought. A single ant does not contain an ant colony's behavior. A single note is not a song. The deeper reality is not always more real in a way that makes the surface worthless. Instead, reality is layered. The surface is the usable face. The depth is the machinery. And your everyday experience is the brain's practical summary of that machinery. It does not show you every molecule in the bread, every photon in the room, every cell signal in your body, every hidden cause behind a mood, every gravitational influence on the planet, every microscopic event beneath a touch. It gives you bread, room, body, mood, ground, and touch. Clear enough to act, simple enough to understand, stable enough to live inside. That simplification is a gift, but it can also become a trap. Because when the ordinary world feels complete, you forget it is only one layer of the story. You begin to think objects are as simple as their names. You begin to think a person is only the version they show you. You begin to think a problem is only what appears on the surface. But science keeps teaching the same quiet lesson. The familiar is often the final shape of something stranger. A cloud is fluid physics made visible. A heartbeat is electrical timing, muscle tissue, pressure, and survival rhythm. A thought is biology, memory, language, and attention, briefly becoming a sentence. A stone is ancient geology holding time in silence. The ordinary world is not less beautiful because it is simplified. It is more beautiful because the simplification works. From a chaos of interactions, the universe produces things stable enough to name, hold, love, fear, study, and remember. So when you look around the room tonight, do not dismiss the ordinary. Let it become transparent. The chair, the wall, the light, the skin of your hand, the quiet air between objects. All of it may be the readable surface of a deeper order. You are not living in a simple world. You are living inside a simplified interface with a reality too rich to show itself all at once. And maybe wisdom is learning to move gently through the surface while never forgetting the depth beneath it.